Hello, Rian. I'm audible. Okay, so fine, guys. I think I'm audible, right? Thank you so much, everyone. Jeet and Ashok and everyone. Yeah, Neelkant, Rupaja, Anup, Sweta, everyone. Yeah, thanks. Okay, so could you copy message option? Unable to copy. Ma'am, actually, I have checked from my end, so I was able to copy the same message. So I don't know, like, why you people are not able to copy, but from my end, so yeah, I'm able to copy messages. So it's not an issue with from my end, I believe. Okay, thank you. Thanks, everyone. Need to update the Zoom. Yeah, so today, just before your class, I have updated my Zoom. So hopefully, once you will update yours, things will work fine, right? And let me just ping a message, right? Hi, kind of a thing. So yeah, just try to do a copy. So let me know if you are able to copy this hi message that I have written over here or not. Yeah. No, I'm not expecting high. So I'm just like expecting whether you are able to copy it or not. Because today I have updated my Zoom. Even I have tested with this one whether I'm able to copy or not. And yes, so some of you are able to copy, I can see, and some of you are not able to copy. So I think it's a problem with the Zoom. You will have to update your Zoom. Then only you will be able to copy. Because from our end, we have already checked. So even as a user, so we have checked, and it's like a completely working for like everyone. What is special today? Everyone praises you. So today, I believe it's 5th September. So maybe you can search on Google. Yeah. So 5th September is known for Saupalli Radhakrishnan birthday, and I think we all know who is he. At least in our childhood, so we all have done these things, right? Thank you. Thanks, everyone. Thank you. Okay, so let's start with the class. Yeah. So today I'm going to talk about a logistic regression, and I have seen some of your messages, right? Saying that you are facing some issue with the deployment. So what I have done is, so I have just forwarded all of your messages to Vikas, and I have asked him to create a separate session and send you a link for that particular session. So whoever is facing an issue with the deployment, so Vikas is going to send you a link, right? So you can try to sit with him, and you can try to resolve your concerns just with respect to a deployment, right? So whether it's a Azure, whether it's a AWS, or whether it's a Heroku deployment that we have discussed, right? So I've already given him an instruction, and yeah, so you must be able to see that I have already forwarded your message. So I have CC'd, copied you guys as well. So those who have sent me a message, right? So he will be taking care of it from our side. Yeah. And in that way, so your deployment issue will be resolved, whatever is the issue. So whether it's a minor or major issue, so it will be resolved from his end. Okay. Now, so moving ahead, and let's try to start with a class. So today I'm going to talk about one topic called as logistic regression, right? So yesterday I was talking about a regression, and that was basically a linear regression that we have studied, right? And we have seen that how we can try to productionize this linear regression, or how we can try to dump this entire things on a cloud. And this is the same thing you will have to do for each and every algorithm. I think GCP is the only one which is pending as of now. Apart from that, so yes, three cloud deployment is done. Fourth is pending. Plus, I have given you a task yesterday, and hopefully all of you are aware about that particular task, right? Integration of ops pipeline, a DVC or ML ops pipeline with respect to a same project that I have given to you, right? So for DVC, there was a community session which is already available, and for MLOps, so I have asked again Vikas to ask a team, a content approval team, to upload those videos inside your dashboard so that you all will be able to use it. MLOps, those who are going ahead with MLOps, those who are going ahead with DVC, that is already available. Again, basic version of this things available in AIOps class. This things has been discussed in a very, very detailed manner. And as I told you, that if you are going to perform well, so for sure, you all will be able to get that particular access. Yeah. So fine, guys, let's start talking about a logistic regression. So now, logistic regression is another algorithm that we are going to discuss or that we are going to see. So what is this logistic regression or how we can try to utilize this logistic regression? So we'll have to understand that particular part in a very first place. Logistic regression. Yeah. So this is the topic that we are going to discuss in today's class. So far, so forth, we were talking about algorithm and we were talking about a model building. And in that particular situation, in that particular scenario, so we have discussed that how we can try to find out a relationship between a data set, right? We can try to build a mathematical equation and a parameter, a known parameter of that mathematical equation. And then that is something called as model. And then we will be able to do a prediction. But the thing over here is, or the fact over there was that we were able to do it. That's completely fine. But if we are looking for some sort of a numerical outcome, again, not an exact numerical outcome. So if we are looking for something like maybe a price or maybe something like a weight or some absolute numerical or real number, right? If we are expecting from our outcome or from our prediction, so in that case, regression is good. And I'll show you polynomial regression as well. So I think I have not shown you a polynomial regression. I'll show you that part as well. So in that case, we can try to go ahead with the regression. Regression simply means that finding a relationship, right? And apart from that, finding a relationship with respect to maybe a real number, right? That is something which is called as a regression. There is another aspect that you will be able to find out inside a supervised machine learning called as classification, right? So regression is one thing and classification is another thing. Again, if you will just go after the name of this algorithm, logistic regression, so it gives you a feeling like I'm just talking about a similar kind of a things or a similar kind of a problem statement. But no, here this is different. So logistic regression is something which can be used for a classification problem. And name of this algorithm is given in a wrong way, you can say. And there are lots of arguments and discussions you will be able to find out over an internet. Someone so you will be able to find a like an argument, so who is justifying the name, and you will be able to find out again an argument, so who is against it, right? So they say that, okay, fine, so maybe logistic classification will be a better name as compared to a logistic regression. Ideal cases, so logistic regression is being used for a classification problem. Now, what is this classification problem? Again and again, I'm talking about, and how this classification problem is different from a regression problem. Let's try to understand that particular part. So let's suppose if I'll ask you to give a rating for a Zomato or maybe for a Swiggy or any kind of a services that you used to avail, or even a rating for iNeuron or anyone, right? So what you will do, you will try to select maybe first, second, third, fourth, fifth as a rating. So 1 star, 2 star, 3 star, 4 star, 5 star as a rating. Again, if I'll ask you a question that whether your class is going good or bad, so you will say good or bad. So either good you will say or either bad you will say. If I'll ask you a question whether you are like a man or woman, so again you will try to say either men or women based on the feature or based on the properties. And again, if I'll ask you that whether you are going for a walk tomorrow or not, so you will say either yes or no. So these kind of a answer or these kind of a things or these kind of a outcome you will be able to see or you will be able to get. So where we are expecting an outcome out of the constant predefined number of the objectives or maybe predefined number of the classes. So these kind of a problems always falls under a classification problem. This is not a regression problem. I'm not expecting some sort of a numbers. So in our very first class, we have asked a question that what will be a weight if height is given. So you can't say that like a weight is maybe like is a part of a classes. So you are supposed to give an absolute number over there. If I'll ask you that how many piece of laptop you will be able to sell next month, so again you will have to give a number. If I'll ask you what will be your revenue of your company or of your division next month or maybe next quarter or maybe next year, Again, you will be talking about a numbers. What will be a temperature tomorrow, right? So in that case, it will be a absolute number which you are going to predict or you are going to forecast. At the same point of a time, if I'll ask you, so whether tomorrow is going to be a sunny or tomorrow is going to be a rainy or it is going to be a cold. So again, you will try to select sunny, rainy, or cold. Out of these three, you will try to select only one, or you will try to predict and forecast only one. So sometime you will be able to see a problem, so which falls under a regression. So where we are looking for an absolute number, a real number, and sometime you will be able to see that we are expecting an outcome as a class, as a absolute classes out of the predefined classes that we already have. So this kind of a problem falls under classification problem, and logistic regression is an algorithm, or you can say it's an equation, so which will help you out to solve such kind of a problem, or I can say a classification kind of a problem you all will be able to solve with the help of logistic regression. So logistic regression, and again, you will be able to see another different kind of algorithm like a KNN algorithm, or maybe a decision tree, or maybe a random forest, maybe a XGBoost. So it may be SVM. So these are a different kind of a algorithm. Again, so the algorithm which I have named, already named. So some of these algorithms is been used to solve a regression problem, as well as it has been used to solve a classification problem. So we are going to see both the aspects. So it's not like we are going to close a regression part as of now, because if there is a linear property, in that case, yes, we can go ahead with the linear regression. But what if we don't have a linear property? In that case, I'm supposed to look for a different kind of algorithm, because according to my problem statement, so I will be expecting a numbers, right? And like a linear regression is going to give you a correct result if there is a linear relation. If there is no linear relation, but if I'm looking for a numbers, in that case linear regression is going to fail drastically, and it is not going to give you an answer. So regression wise, or regression problem wise, linear regression is not the only algorithm which is going to be used to solve a regression problem, or linear regression is not the only kind of algorithm which can be used to solve like these kind of things. There are other algorithms as well. And when we will try to study like suppose a decision tree, or maybe a random forest, maybe a KNN, so at that point of a time, or maybe SVM, SVR, so at that point of a time, we will try to extend, or we will try to explore both the part, regression as well as classification part. And regression and classification, both of these things belongs to a supervised machine learning, because as we all know, as per the definition, that supervised machine learning problem is nothing but a kind of a problem where, so you try to give a feature. At the same point of a time, you try to give a label, so it will try to understand relationship between your features and label, and based on that it will try to generalize the equation part. So logistic regression is one of like such kind of algorithms you will be able to find out. So where we are not looking for an absolute, I can say, a numbers, where we are looking for a classes, yes, no, rainy, sunny, this kind of things, or maybe ratings wise. So these kind of things I'm expecting over here. So now let's try to understand how logistic regression is going to work exactly, and what and all things we are supposed to consider, or we are supposed to take care of. So here is a line we can try to draw. Let me, yeah, okay. So here is a line that we all can try to draw, right? This is the line. So let's suppose this is my x-axis and this is my y-axis. Fine. Now, so let's suppose I have a different kind of objects over here. So let's suppose this is one of the objects, and this is another kind of a object that I have. As you can see very clearly, just by looking into this particular object, that okay, so these two objects is having a different kind of a feature, visual feature, for sure you will be able to observe. And if I'm trying to plot these things on this 2D coordinate, so for sure each and every points, or even a single dot, if I'm going to draw over here, so this is representing two coordinates, or maybe with the help of these two features I can try to represent any of the points which is available over here. So maybe I can try to write down in this things in this way, x1 and x2. These are the features. And what is the final class? So one is a cross class, one is the box class, let's suppose, or square class. So this is nothing but, so label for all of this data set is nothing but, let's suppose, cross. and label for all of these things is nothing but box. So cross and box is nothing but it's my class name, right? So for this data, label is cross. 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 So my feature is nothing but a coordinate. Let's suppose whatever coordinates you will be able to get, x1 and x2 coordinates, right? And my labels features are represented by a coordinates, some numbers. And let's suppose this one is represented by, or labels are represented by a cross for each and every data set. And here, so my labels are nothing but a box, and my features are nothing but a coordinate by which these things is been represented. Now, if I'll ask you that, okay, so I'll give you one new data set. So whether it's a cross or maybe it's a dot. Let's suppose I have given you this data set. Now, if I'll ask you, so whether it's a cross or whether it's a dot. So I think all of you will be able to give an answer, right? Yes. So all of you will be able to give an answer easily. That okay, fine. So this is a cross. Now, if I'll ask you that, can you please try to put this data, right? So this data set for which I have given you a coordinate in either of this section, or can you please try to place this particular data? So yes, what you will do, so blindly you will try to place this data maybe over here, not over here. Why? What is the reason behind this one? The reason behind this one is that majority of the data set which is having a similar kind of a property belongs to this particular region, right? So you will try to put up all of those data in this particular region. Now here, similar kind of a data set is given to me in a numeric format. Let's suppose, so I have a table, right? So I have a table given to me. Let's suppose, so this is a table. So let's suppose this is a table which is given to me, right? Where I have x1 as a feature, x2 as a feature, and then this is a label column. Now, for these kind of a data set, if value is given as 2, 2, and then cross, let's suppose label is equal to cross, 1, 2 is equal to cross, 3, 2 is equal to cross, 2, 3 is equal to cross, 5, 8 is equal to box, 6, 7 is equal to box, 8, 10 is equal to box. Now, if I'll give you a data set that, okay, so let's suppose I have a data set for this range, 5 and 7. Now, what will be a label? So I think all of you will be able to give an answer again, right? All of you will be able to give an answer. So what you are trying to do over here? So you are trying to observe. You are trying to observe a particular pattern. And for sure, all of this x1 and x2 feature, which I have given to you, you all will be able to draw this particular feature in a 2D plane. Easily, you all will be able to draw this particular things into a 2D plane. So let's suppose I have 10 different kind of a feature, x1, x2, x3, x4, x5, x10, right? So again, in a 10D coordinates, I will be able to draw this particular feature. Now, so what machine will try to learn over here? So the roles and responsibility of a machine is to learn a particular pattern. So learn a pattern in such a way that if x1 is given to me and if x2 is given to me, so if x1 and x2 is given to me over here, right? So what will be a label it is going to hold, or what is a label we are going to predict? So that kind of a problem statement falls under a classification. So here we are going to learn a logistic regression. Again, this logistic regression intuition has been derived from a linear regression itself. In case of our linear regression, So we try to draw a line, and we try to draw a line, and we try to do a prediction on top of a line itself. This is what we do in case of a linear regression. So we try to do a prediction on top of a line. Now, at the same point of a time, if I'm talking about a classification problem, so here maybe we can try to utilize such kind of a line. That's possible. So we can try to utilize such kind of a line, but not to do a prediction. So maybe this time we can try to draw a line, or best fitted line we can try to draw to solve some different problems. So maybe to create some sort of a separations in between. So can I say that was just by drawing this particular line, I will be able to create a separation. So for sure, I will be able to separate these two data sets, right? And again, this line is coming from your previous understanding or a previous linear regression itself. So here we are trying to utilize a same line into a different way. In case of a linear regression, so I was trying to do a prediction on top of a line, whereas in case of this one, so we are trying to do what? So we are trying to draw a line, but not to make a prediction, but to separate a data set. So whatever data set we have on one side of the line, so that will be considered as one class, and whatever data set that we have on other side of a line, so that will be considered as another classes, right? So whatever x1 x2 features is given to me, so it is just supposed to draw the line, and then it is supposed to separate all of these features, right? So Akshay is asking that can we classify more than two target variable? So there is a concept called as OVO and OVR. So one versus one and one versus rest, which is applicable into a logistic regression, right? So yes, with the help of that, you will be able to separate even a multi-class, or you will be able to solve a multi-class classification. That is possible in a logistic regression. But again, it's not advisable. That's a drawback of a logistic regression. I'll be talking about it. But yes, so just to answer your question, Arjun, Akshay Arjun, I believe. So yes, it is possible with the help of OVR, one versus rest. That's a concept. Okay. So here is a things that we are trying to solve. So we are just trying to draw a line this time, not to do some sort of a prediction on top of this particular line, but to do, right? But to separate a data points. And yes, so if someone, or with the help of maybe some equation, so if I'm able to find out that what is a probability that this particular given data set, so what I'm supposed to find out, I'm supposed to find out that what is a probability that this data set will be on this side of the line, right? So let's suppose if probability is equal to 0.8. So in that case, can I say that this data set will fall on this side of the line? So always in this case, we are supposed to find out what? We are supposed to find out the probability of occurrence of this particular data set on this side or that side of the line. This is something that we are trying to perform, or this is something that we will try to learn algorithm wise. So this is something which my equations or algorithms will try to understand, or it will try to learn. So just based out of the feature and label. So again, we are trying to establish a relationship between features and labels, but this time in different way while drawing a line. Maybe I can try to draw another line over here, right? So there is a possibility, or there is a chances that I can try to draw this line. So maybe this is line number one, right? This is line number one, and this is line number two for me. So I can draw these kind of a line easily. There is no issue. Easily, I will be able to draw this line. Maybe I can try to draw another line, third line over here, right? So I can try to draw a third line in this particular place. Now, which line is going to be a best fitted line? So can I say that the very first line, line number one that we have drawn, is going to be a best fitted line for me? This is, let's suppose, a line number four that we have. So can I make a statement over here that yes, this best fitted line will be nothing but my white line, or this line number one that I have drawn. So that is going to be my best fitted line. Again, a same kind of a concept. So how I will be able to draw a line? I will be able to draw a line if I'm able to find out a value of M and C. Otherwise, it is not possible, right? Even in last algorithm, we were trying to do what? So we were trying to update a value of M and C, and we were trying to find out the best fitted value of M and C, where error will be minimum or error will tends to zero. This is something that we were trying to observe. And then that on that particular line, so we were trying to do what? So we were trying to do a prediction. This is something that we have done over there. So on this particular line, so we were trying to do a prediction. This time our objective is a little bit different, not like a very different, I would say. Objective is a little bit different. On top of a line, we are not supposed to, yes, we are supposed to draw a line. So we are supposed to learn a best possible line to separate this data set. That's completely fine, right? But prediction wise, so again, we are looking for what? We are looking for a probability, not a value over here. So on this side or maybe on this side of the line, this is something that we are expecting in this particular term. So fine. So I think you all are able to get some idea about a classification, right? Everyone? Yes? At least some idea, right? That what is a meaning of classification and how this particular problem statement is different from the problem statement that we were trying to solve in our previous classes with the help of equation called as linear regression. So over there, what we were trying to do, and over here, what we are trying to do. So hope we all are able to understand it. Now, so again, Surya is saying that so it is used for two classes. No, it can be used for a multi-classes. I'll be talking about a multi-classes as well, right? I think I have already answered to this question. There is something called as OVO and OVR. One versus one versus rest. So one versus rest is been used for a multi-class classification as well, just to make your life easy. So I'm starting ahead with the two-class classification. Binary class, you can say classification. Okay. So here, ideation wise, it's completely fine. We all are able to understand this particular idea. There is no issue. But how and what kind of a equation or what kind of a learning is required, right, to create this particular line or to find out a probability? Because at the end of the day, what I'm expecting a probability of occurrence of this particular object on this side of the line or that side of the line. This is something which I'm expecting, right? So I need some of the involvement of a probability function with respect to what? With respect to maybe a line or something. If somehow I will be able to get a probability, right? Because here my outcome should be what? My outcome should be a probability for all the classes. Let's suppose I have a class called as cross and I have a class called as box. So combined probability of class called as cross as well as box will be 1 at any point of a time. Probability is not going to cross 1, or it will not be greater than 1 or lesser than 0. It will always be in between 0 to 1. This is what, and this is how probability we used to calculate since our childhood. So here I'm looking for a kind of a function, so which can help me out in terms of finding out a probability. And one such kind of a functions we are going to use for a logistic regression is called as sigmoid function. So how many of you are aware about a sigmoid function? So any idea about a sigmoid function? Yeah. So fine, let's try to understand why we are going to use a sigmoid function or how sigmoid function is going to help us out. The idea is to convert this entire solution in such a way that should give me a probabilistic outcome, this side of the line or that side of the line. So this is something which I'm expecting. So equation wise, if I'll be talking about a sigmoid function, so you can try to write sigmoid function in this way. So let's suppose a function of, let's suppose x, right? So it's nothing but 1 by 1 plus. So 1 by 1 plus e to the power minus of x. This is something called as sigmoid function. And if you will try to draw this particular function, so this is the kind of a line you all will be able to observe, right? So let's suppose this is a 0, right? And this is again ranging from minus infinity to a plus infinity, right? And here, so let's suppose I have 1, right? So 0 to 1. Now, if I have to draw a sigmoid function, so maybe I can try to draw a sigmoid function in this way. I think, yeah, drawing is correct. It's a correct drawing, but I think my pen is giving me some sort of a problem. Yeah. So I can try to draw this kind of a line over here. Now here you will be able to find out that whatever value of x I'm going to give on a x-axis minus infinity to positive infinity. So whatever x value I'm going to give, it is always going to give me outcome in between what ranges? So can I say that it is always going to give me an outcome in between 0 to 1, right? Yes. So it is going to give me outcome in between 0 to 1. Doesn't matter what kind of an input I'm going to give. So can I say that it looks like a probabilistic function, right? Because even in case of a probability, so I will be able to get an outcome in between 0 to 1. And if I'm talking about a sigmoid function, so it is trying to give me a similar kind of a outcome over here, right? So this is a probabilistic function, or you can say it's called as sigmoid function, right? So how I can try to make use of this particular sigmoid function and how I will be able to build my complete equations, or how I will be able to complete my learning. So it's pretty much obvious and very much clear that yes, this is a sigmoid function which is going to give me an outcome in between 0 to 1. There is no doubt with that. But how I will be able to use it with respect to a line? Because what is my ultimate goal, or what is my end objective? My ultimate goal or my end objective is to draw a line, and at the end of the day, to find out a probability of occurrence of some object on this side or that side of the line, right? So I think sigmoid has been used for the output layer. So I'm not talking about a perceptron, or I'm not talking about a neural network over here. I'm talking about a simple basic plain regression part, right? So don't try to think in that way. So, and again, so sigmoid function is can be used for a output, can be used as an output function, or it can be used for a hidden layer as well as an activation function. So both of these things is possible, depends upon your nature of the problem that you are going to solve with respect to a neural network. So again, if you will explore neural network, you will be able to learn about these things in that perspective, right? As of now, we are talking about a same function in our logistic regressions perspective. Okay, so here it's completely fine. So maybe if I'm trying to draw a line, right? That's completely fine. But how I can try to fit in that particular line on this probability function? Okay, so just one question to all of you. This is a function that we have, and we are saying that you can try to pass any x values, or for any kind of x values that you are going to pass, right? Any kind of x values that you will try to pass inside this one, it is going to give you some sort of a outcome in between 0 to 1. Fine. I think we all are good with respect to that, right? Okay. Now, let's try to talk about this data set which I have given to you, a sample data set which I have given to you. Yeah. Okay. So here, let's suppose I have two features. Now, if I'll ask you, can you please try to build a linear regression equation, right? What you will do in this case, so just based out of this data set, if I'll ask you, based out of this x1, x2, which is given to you. So if I'll ask you a question that, can you please try to build a linear regression equation based out of that? So you will say that, okay, so here y is equal to, maybe I'll build m1 and x1 plus m2 x2 plus c. So can I say that these are the inputs that you are going to give? Yes, everyone? Yeah. So fine. These are the inputs at any point of a time you are going to give m1 x1, m2 x2 plus c. Yeah. Okay. Fine. So now m1 wise, if I will be able to find out a value of m1, if I'll be able to find out a value of m2. So just a minute, guys. Yeah, I'm back. Okay. So this is the equation which you are going to build. And what you will do, so here you will try to find out a value of y. But what is a value of y that we are supposed to find out for a same x1 and x2. So can I say that I'm not looking for any kind of a real number over here? So instead of looking for a real number for the same input, so I'm expecting what? I'm expecting a probability. Can I make this statement? I'm not expecting any kind of a real number. So what I'm expecting over here is a probability, right? So I'm supposed to learn in such a way that y outcome wise, it is supposed to give me a probability of occurrence of this class and other classes, whatever class is given to me, right? So I'm expecting a probability of occurrence of those classes over here. So my y expectation is not same. It's a little bit different as compared to the previous one. So, and this is the input. This is the input which I'm supposed to let's suppose give, right? So why can't we try to write an equation in this way? So where, so x wise, maybe we can try to write in this way. So probability of x is nothing but 1 by, if I'm looking for a probability, e to the power minus of maybe I can write m1 x1 plus m2 x2 plus c. So can I say that for the same x value, right? So for sure this equation is representing a line, right? This equation is representing a straight line. So for a same x1, because generally what happens is if I'm going to draw the straight line over here, if I'm going to draw any kind of a straight line, so for any kind of a x input, it always try to give me what? It always try to give me y outcome. This is something that it does, right? So here my requirement is a little bit different. So I'm going to like give this particular data or this particular equation a same line. So to do what? So to give me some outcome, and based on that outcome, it is going to give me what? It is going to give me a probability. So if I will be able to get a probability for this input data, can I say that I will be able to solve this particular problem for a classification? So I will be able to get a probability for maybe a cross or maybe a boxes. In that way, yes, I will be able to do a classification. So if probability is lesser than 0.5, let's suppose that is a threshold which I have created. Again, a concept threshold will try to discuss in detail. But let's suppose if there is an object and if I'm going to set a threshold that, okay, so 0 to 0.5 will be a cross class, and 0.5 for sure greater than 0.5 to 1 will be a box class. If this is a benchmark which I'm going to set, so can I say that based out of the outcome of this entire equation, I will be able to solve, or I will be able to predict whether it belongs to a cross class or whether it belongs to a box classes. Is it fine? Will I be able to get it? Yes. Yeah. So yes, I will be able to get it. So here there is a small twist, right? You will be able to find out as compared to the previous equation that we have discussed objective wise, right? So if I have an objective to find out the classes, right, to predict the probability of occurrence of the classes, I can try to use a line, right? Maybe I can try to use a line to create a separations between a data set. But at the end of the day, so if I'm going to put up that particular equation of the line inside a sigmoid function, so I will be able to receive what? I will be able to receive a probability of occurrence. Now here again there is a question, right? Where is a learning part? So can I say that learning wise we are trying to learn this line? Yes. So m1 m2 and c is nothing but it is trying to represent what? It is trying to represent a parameter for drawing a particular line. So again we are just trying to learn the same thing, m1 m2 and c. Apart from this, I'm not able to see anything else which I'm trying to learn, and by using a similar kind of a methodology. Again, for sure cost function is going to be different, it's not going to be same, but this is the whole idea that you all are going to find out. So fine, let's try to see a certain derivation so that I will be able to clarify these points in a much better way, right? So let's suppose I'm looking for a probability. So let me show you a derivation of this one. So for sure this probability equation is nothing but 1 by 1 plus e to the power, maybe I can write in this way, minus of maybe beta 1x, which is nothing but m1, and a beta naught, right? Which is nothing but equivalent to a c. So slope and intercept I'm trying to represent over here. So this is a line equation of the line, and this is my probabilistic function in this particular place. Now, if I'll try to normalize this probabilistic function, so maybe I can try to write it down in this way. So P of x is equal to nothing but I can say e to the power beta 1 x plus beta naught divided by, I can try to write down 1 plus e to the power beta 1 x plus beta naught. So after normalizing, or after like doing this multiplication and division by 1 plus minus e to the power minus of beta 1 x plus beta naught. So fine. This is, maybe I can try to call these things as a equation number 1. This is the equation number 1. Again, these two equations are the same. I've just like normalized this particular equation with numerator and a denominator over here. Now, this is a probability which you will be able to get from one class. How I will be able to get a probability for another classes? Any idea? So let's suppose I will be able to get a probability for one classes. I have two class. So if I'll ask you how I will be able to get a probability for the another class, right? So you can say that, okay, probability of another class is nothing but 1 minus P of x. So I think all of you will agree. So again, 1 minus P of x. So 1 minus in this side. So left hand side, we can write 1 minus P of x. In right hand side, again, I can try to write 1 minus e to the power beta 1 x plus beta naught divided by 1 plus e to the power beta 1 x plus beta naught. Fine. So this is, again, I can try to write it down. Now, if you will try to normalize these things, right? So you will try to take this particular factor over here. So if you try to normalize this particular thing, so what will be the answer? What will be the final result that you all are going to get? So can I say that 1 minus P of x is nothing but 1 by 1 plus e to the power beta 1 x plus beta naught. Are you able to get this equation, or shall I derive these things? So just you have to take a normalization of this one, and 1 plus e to the power beta 1 x minus e to the power beta 1 x plus beta naught, and this particular factor will be cancelled out, right, in both of the side, and simple, right? So how beta came to the equation? So simple, I'm just trying to represent this one. This equation is what? This equation is the equation of y is equal to mx plus c. So can I say that this is equivalent to mx plus c? So instead of using mx plus c, I'm just using m and c. So I'm just using a notation as beta 1 and beta naught, nothing else. Is it making sense to everyone? Yes. So anyone who is like confused over here till this point of time? No. So this is my equation number 2, I can say. So I have equation number 1, where I'm trying to find out the probability of one object, and then for another object, probability will be 1 minus P of x. So this is the equation which I will be able to get, right? Because I have two classes. So I'm just trying to do a binary class classification. So let's suppose I have a class called as cross. I have a class called as box. So for C, P of x is a probability, and maybe for a B box class, so I have a probability is equal to 1 minus P of x, right? Simple. I will be able to get it over here. Now, so what we can do is, so maybe we can try to divide equation number 1 by equation number 2. So let's try to divide equation number 1 by equation number 1 by equation number 2. So how e power minus becomes plus? Okay. So there is a question that how we are able to get this particular part. Okay, I'll try to show you in a very simple way. Let's suppose I'm writing 1 by 1 plus e to the power minus of x. Now, same equation, I can write it down in this way. 1 by 1 plus 1, so by e to the power x. Is it fine? Yeah, is it fine? Okay, so just a childhood way. and then I can try to write it down 1 by, so I can try to take a normal like a denominator, so e to the power x plus 1 by e to the power x, right? So now if I'll try to just like take this denominator as a numerator, I can write it down in this way, e to the power x by e to the power x plus 1. So this is how we are able to get this. So we are able to get this one out of this one. Is it fine? I think it's just a childhood things, right? So we all have done this kind of a things in our childhood. So I'm assuming that we all are able to understand it. But yeah, it's not an issue. इस तरह से ये खेल बहुत लंबा चलेगा. So yeah, what we can do, like we have to understand each and everything, right? Okay. So now let me do one thing. So maybe we can try to divide equation number 1 by equation number 2. So if we are going to divide equation number 1 by equation number 2, then what we can try to write over here. So let's try to divide equation number 1 by equation number 2. So can I say that I will be able to write in this way? So P of X divided by 1 minus P of X, right? So I'm just trying to divide equation number 1 by equation number 2. And on this particular side, so what is my P of X? So my P of X is e to the power, let's suppose beta 1 X plus beta naught. I'm representing as theta, so that I will not have to write it down again and again, right? Just for your reference, I have already given you a reference. So e to the power theta over here divided by 1 plus e to the power theta over here, right? So again, don't ask me what is theta. Theta is nothing but this one. This one I'm trying to represent as a theta, so that I won't have to rewrite this again and again, b1x plus b naught, right? It will have theta. So again, divided by, so equation number 1 divided by equation number 2. So 1 by 1 plus e to the power theta, let's suppose. Okay. So if you are going to solve it, so can I say that this and this will cancel out, and you will be able to see what? E to the power theta. So can I say that it is going to be P of X divided by 1 minus P of X is equal to e to the power theta. Is it fine? Yes? Yeah. So this is something that you all will be able to find out. Now, if this is a situation, and if I'll ask you to take a log, on both hand side. So if you are going to take a log on both hand side, so log on this side and log on this side, just to normalize this entire equation. So what you will end up writing? So can I say that log of P of X divided by 1 minus P of X is equal to, so log of E is equal to e to the power theta is equal to, can I say theta? Yes. Now I can try to write a theta equivalent. So what is my theta equivalent? Beta 1x plus beta naught, right? So this is equations that we are able to derive. Now, why we are deriving this much of equation? Let's try to get into a conclusion now. Okay. So this is an equation that we are trying to derive over here, right? So can I say, just by looking into this entire equation, that we are trying to represent somehow, so we are trying to represent a complete line. So a line in a form of a log and probability, or I can say, so can I say that we are trying to represent a complete line as a logit function? Yes. So we all are trying to represent this entire line, because this beta 1x plus beta naught is nothing but it's a line mx plus c, right? And we are trying to represent this function, this line, as a function of what? As a function of a logit function, a probabilistic function. So where we have a probability of one object as well as we have a probability of another object in this particular place. Fine, no issue. Now here, so this is a logit function, and again, this is called as a logistic functions as well. This is something called as logit function or a logistic function in this particular place. Now here, right? So here, can I say that if probability is lesser than 0.5, right? If probability is lesser than 0.5, if P of X is lesser than 0.5, in that case, what will be the outcome? Okay, so I think you all have a calculator, right? Now just do one thing, right? Just do a very small calculation. I think this idea will be very, very clear to all of you, right? So I'm just saying that let's suppose if value of P of X, right, is lesser than 0.5. So let's take a value as 0.4, let's suppose. So let's take P of X is equal to 0.4, right? Now, what you will be able to get on this side? So what is a log of 0.4 divided by 1 minus 0.4? So what will be a value of log of 0.4 divided by 1 minus 0.4? So log of 0.4 divided by 0.6. So what will be a value? Okay, so let's suppose log E I'm talking about. So base is E. I think you all are trying to calculate maybe based on base 10. So what is the value that you will be able to see? Or what is the value that you will be able to get? Anyone who can give me a correct result or correct answer? Yeah. Okay. So now just try to like calculate one thing, right? So just try to calculate for maybe a value greater than 0.5. So just try to take any values, 0.6, 0.7, and then try to do some sort of a calculation. Okay, so for P of X is equal to 0.7, so it's coming as 0.367. Okay. So for 0.6, it's coming as 0.17. Positive for greater than 0.5 and negative for lesser than 0.5. Okay. For P of X value 0.8, so it's coming as 0.6. So less than 0.5. So you must have observed that whenever you are going to take any values which is lesser than 0.5, so it must be giving you some of the result, right, in a negative. And whenever you are going to use maybe some values which is greater than 0.5, so can I say that it is giving you a positive value? Yes. So for lesser than 0.5, it is giving you a negative values, and for greater than 0.5, so it is giving you a positive values, right? So greater than 0.5, positive, and lesser than 0.5, it's going to be a -1. Now, anyone who can explain me a meaning of this? What is the meaning of this one? Anyone? Any idea? I think you all have done this kind of experiment that whenever you are taking like a value lesser than 0.5, it's giving you a negative values. And for greater than 0.5, it's giving you a positive value. So any idea? Yeah. So Arjun is saying above and beyond the line, it varies between -infinity to +infinity. That's incorrect. If value greater than 0.5, then we should accept it. No, not at all. So I think only one person has given me a correct answer, and as a positive and negative. So can I say over here that y value for this particular one, or I can say that y value, or let's suppose I'm able to get some negative values, right? Maybe negative value is equal to minus 0.17. 0.17, right? So can I say that this is going to be what? So this is going to be my y. Yes, this is going to be my y in that case. Can I say that we are trying to draw a straight line, right? So maybe I can try to say above and below the line, right? So this is the line which I'm trying to use as a separator line. So maybe I can try to label these things as a negative reason or vice versa, right? So, and this one as a positive reason. So can I say that by solving this particular problem, so if I'm trying to give a probability is equal to lesser than 0.5, probability of occurrence of anything is equal to lesser than 0.5, right? So in that case, so what is a reason I'm able to get? So in one side of the line, I'm able to represent the object, and if it is giving me a positive result, so in that case, I'm trying to represent a same object on a another side of the line. So maybe on a positive reason or maybe on a negative reason. So I will be able to represent a line. So can I say that this is a kind of a result I was expecting? What kind of a y you will expect? How you will say that this particular object belongs to this region or that region? So can I say that you will be able to represent it once you will be able to find out whether it belongs to above or below? Yes, everyone? Yeah. So probability and how we are getting a probability. So just try to recall a same sigmoid equation. So can I say that sigmoid equation is going to give you a probability, and it is going to give you a probability based on what? So based on the straight line plus input data set that you are going to give, right? And based out of that, so we are trying to calculate over here what will be my y. So whether this belongs to this region or that region. So let's suppose in this region, so I'm trying to represent all my cross, and in this region, all of my I'm trying to represent my boxes. So it's very simple. Again, so whatever falls under this region, it will become a cross automatically, and whatever falls inside this region, so it will become a box automatically. And this is kind of a separations which I am expecting in this particular place. So this is a representation of a y. So in general, you will be able to find out that this kind of a statement you will be able to find out. So y is equal to maybe a 0, right? If probability is lesser than 0.5 and y will be equal to 1, means I'm just trying to talk about the binary classes. So one classes versus another class. So if probability is equal to 1, so in that probability is equal or greater than 0.5. So in that case, it will become 1. Or you can say 1 is representing a negative reason and 1 is representing a positive reason. Again, this is just a representation that you will be able to find out. So this is a final logit function that we have derived out of what? Out of 1 by 1 plus e to the power minus of x, which is responsible for giving me what? Which is responsible for giving me probability. And what is my x? It's nothing but a straight line. Based out of that, I'm trying to calculate a probability. And based out of this probability, so let's suppose if probability is something which I'm able to find out, right? Based out of the line. So in that case, can I say I will be able to find out y? If someone will give you a probability, so can I say that you will be able to find out y? If someone will be able to give you y, so can I say that that you will be able to define it will belongs to this like a negative reason or positive reason, or zero reason or a one reason, or a reason or a b reason. Yes, I will be able to predict. Now someone has asked me a very good question. So how you choose a value is equal to 0.5? This is something which I'm going to explain you in the same algorithm, but in a later stage, because that particular part is very, very important. So how the question which people is going to ask you in an interview is how you decide a threshold. Because here I'm saying that whatever comes below 0.5, so that will become one class. Whatever comes above 0.5, that will become another classes. This is the generic perceptions that we are trying to build. But no, that is not a case. So I'll teach you even over here that maybe my threshold can be 0.7. So whatever comes below 0.7, that will become one classes, and whatever comes above 0.7, that will become my another classes. So how I will be able to adjust my thresholds, and what is a roles and responsibility of a thresholds, that you will be able to get. So this is the kind of a direct questions which you can receive in your interview, and that's a very interesting question that people generally ask, right, over here. So fine, but people use a logistic regression for in a multi-class classification. People generally don't use a logistic regression for a multi-class classification because of its behavior. It is not going to perform well because it will become one versus rest. But I'm not denying a fact that you can't use logistic regression to solve a multi-class classification. Yes, that is possible, and that we will try to discuss over here. So it's completely fine. Here we are trying to find out the y value, or we are trying to find out that my data set belongs to this region or that region based on the straight line. Now, if I'll talk about maybe its cost function. So for sure, to find out the probability, right? Now, to find out the probability, can I say over here, or can I make this a statement in this particular place, that if I have to find out a probability P of X, so here I'm supposed to find out minus of mx plus c, right? And this m and c, can I say that this m and c is nothing but it's a learnable parameter, right? Because what is my ultimate goal? My ultimate goal is to find out the probability of occurrence of one classes. If I'm able to find it out, so in that case, I will be able to find out the value of y. If I'm not able to find out the probability, in that case, I won't be able to find out a value of y at all. So here, my objective is to find out what? Objective is to find out the probability. So correct probability, I will be able to find out once I will be able to find out a correct value of m and c. Is it fine? Yes. So can I say that this is something that we are supposed to learn? So our learning parameter, learnable parameter is nothing but m and c in this particular place. And here, in case of our linear regression, if you remember, so what is a cost function, or what is a loss function that we have been using to find out a value of, or to tune a value of m and c? Anyone? So can I say that we were trying to like find out a residual over here, right? Or root mean squared. So we were trying to do over here. We were trying to find out over there. And based out of that, we were trying to calculate what? We were trying to calculate a cost or loss or error. How we were trying to find out this error? So can I say that it's nothing but a difference between y and y hat square? This is how I was able to find out what is a difference between y and y hat, or expected and the predicted result. And based out of that, I was trying to adjust a value of m and c. And I think you all remember a 3-pen concept which we have discussed, right, at that point of a time. So we are supposed to bring it down. So we are supposed to bring down our error on a surface where error will be equal to 0, and at that point of a time, it is supposed to give me a value of m and c. That is something that we have discussed. In that cases, is it so is it possible to use a same residual cost function over here to tune a value of m and c? Half of you are saying yes, and half of you are saying no. So some of you are saying, I think yes. So whatever you are thinking, so I think it's incorrect. Yeah. So, okay. So it is not possible because it's a non-linear one. Now just tell me one thing, right? How it is going to be a possible? I'll give you one situation, right? Those who are saying yes, so that you will be able to understand. In case of our linear regression, I was trying to find out something on top of a line, right? So let's suppose I was trying to give maybe my X as an input. And then for the respective X input, it was trying to give me what? It was trying to give me a Y. So let's suppose this is a actual point. This is the actual point, right? So for this actual point, this will be the X for sure. This is going to be my X. Now, this is my actual Y. And this is my predicted Y out of the line, which I'm trying to predict. So I was trying to find out this distance, or I can say I was trying to find out this distance. What is the difference between Y and Y hat over here? In case of a linear regression, or we were trying to say that as a RMSE or maybe MSC value, we were trying to find out a summation of all the residuals we were trying to find out, and we were calling that as a loss function or maybe a cost function. Yes, or maybe error we were trying to say, and based out of that error, I was trying to adjust a value of M and C. Right now here, are we trying to follow a same case? Because here in this case, line is same, right? But what is my problem statement? So I have to do a classification of an object, right? So for this input, let's suppose if I'm talking about one input. So for this particular input, am I looking for some of the Y value on top of the line? No. What I'm expecting over here, I'm expecting a probability. So let's suppose this is a reason 1 and this is a reason 2. So I'm looking for a probability, that what is a probability that this object will belongs to a reason 1 or a reason 2. So can I say that I'm looking for a probability? Yes. So if I'm looking for a probability, so can I say that in a previous cases, I was expecting a similar kind of a Y, right? But here, this is not the case. I'm looking for a probability. So can I say that in case of probability, so I'm not supposed to use a same cost function or error function. So what you are going to do? So you are going to sum up all the probabilities, and then you are going to say that as a error. Because in last cases, right? So yes, you were trying to sum up all the residuals, means all the distances. So average distances you were trying to consider as a errors, and based on that you were trying to change your value of M and C. So are you going to sum up all the probabilities and then you are going to say this is the total error? Yes or no? No, for sure. So those who said yes, so I think they are able to get an answer. Those who said no, so let's try to find out that what kind of a loss function I will be able to use over here, right? So that was an answer for people who were saying yes. So hope you are able to get your answer in this particular place, right? Now here, so there will be a different kind of a loss function or cost function which is required. A kind of a cost function which should be based out of the probability for sure. Because unless and until I'm not going to use such kind of a loss function which is based out of the probability, I will not be able to find out my solution. I will not be able to change a value of my M and C, and I will not be able to draw a line which is going to separate my instances in a neat and clean way, right? So here your cost function that you are going to use, right, will be different for different instances. So let's suppose I'm talking about two classes. So class 0, and let's suppose I'm talking about a class 1. So what will be your cost function? So your cost function is going to be, let me use a white pen. Yeah. So your cost function is going to be a function of a probability, and I can say the actual Y or the actual probability that you were expecting. So can I say that let's suppose this is a line, right? So lesser than 0.5, lesser than 0.5 is been represented by reason number 1, and greater than 0.5 is been represented by a reason number 2 over here, right? So this region is representing lesser than 0.5 and this region is representing greater than 0.5. So for this object, can I say that I was expecting basically a probability, any probability greater than 0.5? But let's suppose for this one, so I was able to get a probability based out of this line, So I was able to get a probability is equal to 0.4, which so ideally, so it is this my equation is trying to give me a prediction that this object belongs to which region? This object belongs to this region. But my actual value says that no, this object belongs to this particular region. So can I say that my cost function will be a function of a probability, right? That I'm going to predict, let's suppose P of X based out of this line plus the actual probability that we already have. So that should be a function, right? So here, if you will try to write it down, so maybe you can try to write it down in this way. So the cost function for one of the classes, for class is equal to 1, will be nothing but negative of log of, I can say, so negative of log of P of X. P of X. So if your Y is equal to class number 1. And if your Y is equal to class number 0, so in that case, your probability will be what? So your probability will be nothing but log of 1 minus P of X. So for Y is equal to 0 over here. So this is a cost function or this is a loss function. You will be able to find out. Now you will ask me a question that how you are able to do these things, or whether I'm supposed to remember this particular cost function or loss function. My answer will be no. So I'll tell you how I'm able to achieve this one. But just as of now, just try to remember for one of the classes, cost function will be minus of log of P of X. And for another classes, it will be nothing but minus of log of 1 minus P of X, right? Again, some of you will say why minus and how we are able to get this particular function, which is a valid question for sure. And I think we all are supposed to find out an answer for the same thing, right? Fine. Now, so I'll just give you one situation over here. So if probability is equal to 1, right? If probability is equal to 1, so what will be the value of log of 1? So what will be the value of minus of log of 1? Can I say it is going to be a 0? So can I say that value of cost is equal to 0? If P of X is equal to 1, if probability is equal to 1, right? So in that case, can I say that cost function is equal to 0? Now, what is the meaning of cost is equal to 0? So can I say that cost is equal to 0 means your expected and a predicted both is same? Can I say same thing is been mentioned over here? So same thing is mentioned over here, right? So I was expecting Y is equal to 1. And let's suppose if probability is equal to 1. So in that case, what will happen? Cost is equal to 0. It simply means that this one and this one is equal. There is no error, right? Okay. Now, so if probability is equal to 0, so if probability is equal to 0, and if my if probability is equal to 0, and in that case, if expected Y is equal to 1, so what will be a log of 0? What is a minus of log of 0? Can I say that infinity or 1? If probability is equal to 0, right? So in that case, can I say that it is going to be a infinity? I think some of you are saying 1, 0 as well. So use your calculator, you will be able to find out infinity, right? So can I say that cost is equal to infinity? So I was expecting Y is equal to 1. Now system has given me probability is equal to, means Y is also a probability over here. In terms of probability, I'm trying to define. So let's suppose I was expecting Y is equal to 1 and probability is equal to 0, right? So in that case, cost function will be very, very high. Means it's an infinity, means we have so much of error. Again, let's try to evaluate. If expected Y is equal to 0 and probability is equal to 0, expected Y is equal to 0 and probability is equal to 0. So can I say that I will be able to use this equation, right? And in that case, what will be the cost? Can I say that cost is equal to 0 again? Means there is no error. Okay. So validation wise, we are able to understand, okay, fine. So this is the cost function, which is a valid cost function we are trying to use, right? There is no issue with that. But again, same question is from where we are getting this equation. So what is the actual cost function from where we are able to derive this particular function, right? That's a major objective over here, because just based out of the cost function or loss function that we are using, it is going to tune the value of M and C. So if there will be a differences, in that case, it will try to change a value of M and C. So it will try to find out the new value of M and C. So M new is nothing but M old plus minus eta into delta of E of M. I think we all are aware about it, right? A same equation that we have derived in our previous classes. Simple. So here, if I'll talk about a cost function, a whole cost function, you can try to define in this way. And this is something that you are supposed to remember. So cost function for any logistic. So cost function for a logistic regression is nothing but 1 by M, right? So this is again a simple one. It's not very tough to remember. Summation of I is equal to 1 till M, where M is nothing but a number of instances that you have, or number of record, or number of rows that you have, right? Plus over here, so yi, you can say, so ith y, so whatever expectation that you have, and log of p of x or I, plus you can say 1 minus yi log of 1 minus p of xi. This is an actual cost function that you will be able to see at any point of a time. So this cost function which I have written, so this is another cost function equation that you will be able to find it. So I think we all are aware about RMSE or MSE equation. So in the similar way, this is the another equation of a cost function that you all will be able to find out, which says that minus of 1 by M y log p of x plus 1 minus y log of 1 minus p of x. So here, summation of the total error for any of the classes, so whether it's a class 0 or whether it's a class 1, is nothing but it will be a summation of all the instances, so which is trying to do a prediction for a y, or it is trying to do a prediction for a reverse of or 1 minus y. So this is the actual equation. And then if you will try to identify, or if you will try to derive this one based on each and every like a single instances. So let's suppose y is equal to 1. So y is equal to 1 class, we are trying to derive the same thing. So if y is equal to 1, so in that case, can I say that this particular factor will become 0 if y is equal to 1? So for class number 1, if I have to find out what will be the cost function, so 1 minus 1, so this entire entity will become 0. And can I say that this will become minus of log of p of x? So can I say this is the same thing we have written over here for y is equal to 1? So I'm just talking about class wise. Here, this is the combined equation for any classes, right? For like class 0 or class 1. Now, so if y is equal to 0, so in that case, can I say this entire factor will become 0? If y is equal to 0, means for another class, if I'm trying to find out the cost function, so this entire factor will become 0, and then this factor is going to be minus of log of 1 minus p of x. And this is what we have written over here. So these two things is coming out of from this equation, and which is not difficult to remember. It's very, very easy. So y into log of p of x plus 1 minus y into log of 1 minus p of x. So for one class and another classes. So one is representing class number 1, another one is representing class number 2. Or you can say 0, 1, a, b, x, y, whatever it is, right? So this is a kind of this equation is called as a log loss equation. And we are trying to use this equation for finding out a cost function for this entire logistic regression. So this equation is going to give me what will be a loss, and then based out of this loss, I will try to tune a value of what? I will try to tune a value of M and C. So let's try to consider one of the case over here. Let's try to understand one of the case over here, and manually let's try to do some sort of a calculation in this particular place by using all of these equations. So whatever things we have learned so far, so forth. So maybe based out of that, so let's try to do one manual calculation so that everything will be clear and we will be in sync, right? So here, let's suppose we are going to take one data set, right? So let's suppose a data set is equal to 2, right? And class is given as 1 over here. Data set is equal to 3. Class is given as 1. Data set is equal to 0. Class is given as 1. Data set is equal to, again, 4. Class is given as 1. And data set is equal to 5. Class is given as 2. Data set is equal to 8. Class, or sorry, maybe I can write class number 0 over here. I can give any classes, right? So class x is equal to 8, class is equal to 0, x is equal to 9, class is equal to 0, x is equal to 7, class is equal to 0. Now, this is a data set which is given to me. So where one feature is given to me and we have two classes. Then similarly, we can try to do the same thing for a multiple features. So multiple x values. So as of now, just try to consider we have x and we have a y over here. So labels are given to me and features are given to me. Now, very clearly, you are all able to see that whatever value we have, which is lesser than or equal to 4, it's having class is equal to 1. And whatever value we have, which is greater than, well, let's suppose 4, so class is equal to 0, right? So class is equal to 0. Now, here we have certain objective. So here we have to find out a value of m and c so that I will be able to separate, or maybe I have to draw a line so that I will be able to separate these two data set. That is my objective over here, right? So just to draw a particular line in this particular place. Fine. So here what I will do, I'll try to write an equation p of x, and p of x is nothing but 1 by 1 plus e to the power minus of maybe mx plus c. This is something which I'm going to write. I'm not aware about a value of m and c as of now. Fine. I'm not aware about m and c values as of now. So I don't know what kind of a straight line I'm going to draw, right? Literally, I don't have any idea. Hypothetically, let's suppose I'm going to take some random value of m. So let's suppose m is equal to what? So m is equal to 5 and value of c is equal to 2. Value of c is equal to 2. This is the value of m. This is the value of c, right? Okay. Now just try to tell me one thing. What will be a p of x for a very first data? Everything is given to you, right? Value of m I have given to you. So value of m and c, I have taken this values as a random values. So let's suppose value of m and value of c is given to you, right? Now tell me, so what will be a p of x for 2? Okay, so p of x, people are saying as 0.99, right? So fine, 0.99 is a p of x, people are trying to say. I will try to take a value of m is equal to, let's suppose 21, and value of c is equal to minus 5. Now give me a value of p of x. M is equal to 21 and c is equal to minus 5. Okay, so it is going to be 1, let's suppose, right? So in that case, probability will be equal to 1, I would say. Now, let's suppose I'm going to take a value of m is equal to 0.3 and value of c is equal to 0.1. Now, what will be the value of P of X in this case? 0.3 and 0.1. What is the value of X? I already told you, right? So value of X is equal to 2. You are supposed to consider this one. So X is equal to 2. A very first instance I'm talking about. Yeah. So fine. People are saying 0.66, right? Or 0.67, I can write. 0.67 is a value that I will be able to see. Okay. That's great, right? So in one case of M and C, I'm able to get this value. In one case of M and C, I'm able to get this value. In other case of M and C, I was able to get this value, right? Now, for this case, what is a probability or what is a class value which I was expecting? I was expecting 1, right? Yes, I'm able to get a probability close to 1. Now, let's try to calculate a cost, right? So let's try to do one thing. So let's try to do a cost calculation. So if you will try to do a cost calculation, so what will be your cost? Because I think I'm aware about a Y, right? I'm aware about a probability. So I will be able to do a calculation. So let's try to do a calculation. So let's suppose P of X is equal to 0.99 and your Y value is equal to 1. Now tell me what is the probability. Sorry, cost. So maybe I can write cost of this 2 for this instance, 0.99 instance. What will be your cost? I think it's a straightforward calculation, right? You don't have to even calculate much over here. So it is going to give you maybe 0.01, 0.001 or something like that. It's clearly visible over here, right? So cost is equal to 0.1. Okay, fine. So cost is equal to 0.1. I'm going to write down. So cost is equal to 0.01. Cost is equal to 0.01. Can I say that in this case, cost will be approximately 0? Now, what will be the cost in this case? Someone is saying 0.004. So what will be the cost in this case? So can I say 0.33 will be the cost? 0.33 will be the cost over here. In this case, third case. So when I have taken this as M and this as C, just try to focus over here, guys, for some time. So I'm discussing each and everything in this particular place itself. Yeah. So this is the cost that you will be able to find out, 0.33. So now I have situation number 1, I have situation number 2, I have situation number 3. So in which case I'm supposed to change my separator or change my line more? So can I say that in case number 3, I'm supposed to change a value of M a lot, right? So what I'm supposed to do is, so I'm supposed to find out a new value of M. So M new I'm supposed to find out over here. And M new is what? M old minus eta of delta of E with respect to M. So can I say that this is the equation that we have discussed? Again, similar kind of equations for a value of C. So this is the equations that we have discussed in our previous classes. So eta is nothing but it's a learning rate, and delta of E of M is nothing but rate of change of error with respect to a M, right? So can I say that I'm able to find out my error over here easily? I'm able to find out the error, right? So based on my error derivative with respect to M, I will be able to find it out, right? Now, what is the error function? Can I say this is the error function that we have? Yes. So can I say that if this is the error function, I will be able to find out the derivative of this error function? Yes. So I will be able to find out a derivative of this error function. Someone is saying that how cost of 2 is equal to 0.1. So I'm calculating with respect to this one. So I'm just going in sync. So for m is equal to 5, 2, c is equal to 2. This is the value. M is equal to 21. C is equal to -5. This is the value. So I'm just moving in this particular direction. Okay. So can I say that I will be able to find out if so I know I'm aware about a previous m. So what is the previous m for this case? Where we are able to get cost is equal to 0.33. So can I say that my previous m is nothing but 0.3, right? So my old m, so I'm aware about this old m value. This is 0.3, right? Maybe I can try to keep eta is equal to 0.01, right? Because we all know learning rate is nothing but it's a like a parameter which we can tune. It's a hyperparameter, right? So I can try to use eta is equal to something. Now, what will be the value of delta of E m over here? Any idea? Yes. So how I will be able to get this delta of E of m? So what we have done in our linear regression case, same as linear regression, is it? Error function in my linear regression was different. I have discussed a different error function over here. So how it is going to be same? So how you are saying and why you are saying that it is going to be same in both the cases? Okay, so Nilesh has given me one equation over here, and yes, it's correct, I would say, right? So Nilesh has given me one of the equations. So let me just copy and paste that equation if it is possible. I don't know whether it's possible or not. Yeah, so he has given me this equation. So 1 by m sigmoid of p of x yi into x of I. So this is the equation that he has given me, which is representing, which he's saying that it is representing delta of E of m. Now, how we are able to get this equation? So we are able to get this equation after finding out a derivative of, I would say, a same cost function. In the similar way, we have found out a derivative of our residual function or a error function in our linear regression cases, because we are looking for a derivative, right? And if I'll ask you to find out the derivative of cost function, right? So d by dm and a d by dx. So can I say that we all will be able to find out? Yes or no? Will I be able to find out a derivative of these things? Yes. Okay. So let me make this life a little bit easier for all of you again. How, so some of you must be like confused that how I will be able to find out derivative of these functions, right? So let me give you certain clarifications over there. So this is my cost function. So we all are aware about it. So this is my cost function now minus of 1 by m. I'm not considering this summation symbol as of now. By default, you can consider it there. So y, then log of p of x. So can I say that I can represent this log of p of x is equal to 1 by 1 plus e to the power minus of x, where x is nothing but y is equal to mx plus c. Yes. So here, yeah, so p of x is nothing but it's a y hat for us, right? So it's nothing but it's a y hat for us, which is a function of, I can say, or it's a sigmoid function, right? So maybe I can try to represent this one as a sigmoid function. So let's suppose sigmoid functions of this theta. Theta is nothing but mx plus c, and this is representing my sigmoid function. This is representing my sigmoid function over here. Plus again 1 minus y, right, into log of 1 minus sigmoid function. So I can try to represent in this particular way, right? So I'm just trying to represent p of x as a sigmoid function where theta is nothing but mx plus c, and sigma is nothing but it's representing your sigmoid function. So now if you will try to find out a derivative, so rate of change of, right? So rate of change of this entire equation with respect to what? So with respect to M and C. So yes, I think it's possible. It's possible to find it out, right? Because everything we have a M over here, right? And we will be able to find out E. We will be able to find out X, which is nothing but your Mx plus C. So yes, you can just try to find out the derivative and you will be able to get. I'm just going to write the final equation over here. So you all will be able to see, or you all will be able to get a same equation which Nilesh has mentioned. So 1 by m and sigmoid of, I would say, p of x minus y into xi. So this is something that you all will be able to see, or you all will be able to find out. So p of x, as well as it will be a function of a theta. So both this probability will be a function of x as well as theta. Pi square plus c. So xi. So this is nothing but this will be your delta of E with respect to M. This equation. So if I'm aware about this equation, so yes, I will be able to find out what? I will be able to find out a delta of E of M. And once I will be able to find out this delta of E of M, I will be able to calculate a value of nu M. And this is what we are supposed to do. So each and every time. So I'm supposed to, so stepwise, if I'll try to conclude this entire steps, what we have done? We have taken this very first step, simple, right? Then we are trying to find out what? So we are trying to find out the probability. Once we are able to find out the probability, we are trying to find out what? A cost. Once we are able to find out the cost, we are trying to find out the new value of M. So can I say that we are actually just trying to take 3 steps over here? Eta is a random number. So basically, if you're talking about this one, right? So this is nothing but it's called as a learning rate. And I think I talked about a learning rate. So whenever you will try to come down from a mountain, right? So you will always try to maintain your pace. It's not like you will like just run from here to here, because this is not a smooth surface. So you will try to always like take a smaller step. So that step will be controlled by your learning rate over here, right? So this is something that you all will be able to see, or you all will be able to find out. So is it fine with everyone? So if I'll try to summarize this entire thing, so we have used this one equation, we have used this second things called as cost, and a third thing. That's it. Just in 3 ways, so we can try to summarize this entire things. And yes, I will be able to adjust a value of M and C, because this is what I was expecting. I'm supposed to draw a line. I'm supposed to draw a straight line, which is going to give me a clarification that, okay, so my data will belongs from a negative reason, or my data will belongs from a positive reason. So if I'm aware about this particular line, if I'm aware about its M, if I'm aware about its C, right? Now, if I'll give you one another data set. So let's suppose if I'm giving you a new data set called as maybe 6.5. Let's suppose this is a value of M 0.3 and 0.1 is a value of C. So we have a value of M and we have a value of C. Now, if I'll ask you, what will be your Y? If you can give me an answer. So based on value of M and C, which I have given to you. So what will be the value of Y? So I'm looking for a prediction. So what is the value of Y that you are going to give me as per the calculation? Yes, anyone? So what will be the value of y over here? I think I have given you a value of m, right? And I think I have given you a value of c. I have given you a value of x, right? So can I say you all will be able to find out the probability p of x? So what will be your probability of p of x? If value of x is equal to 6.5. Okay, let me write it down over here. So if value of m is equal to this value, same value which I have given you last time, 0.3, and 0.1 is a value of c. So value of m is equal to 0.3, value of c is equal to 0.1, and value of x is equal to 6.5. What will be p of x? Calculate. It's very simple, right? So I can try to use this equation, 1 plus e to the power minus of mx plus c. So what is the value of p of x? Someone is saying 0.12, someone is saying 0.88, someone is saying 0.89, again 8873. So why this many values we are able to get? I think it's a straightforward calculation. So just try to do a calculation and give me values of this one. And remember, it's a negative symbol that we have. So e to the power minus of mx plus c we have. Okay. So now, so if you are able to find out a value of this one, a value of p of x, so can I say that what is our logit function? So logit function says that it should be a log of p of x divided by 1 minus p of x is equal to mx plus c, right? So now try to find out a value of this side. Okay, so 2.05 or 0.56, 1.99, again close to 0, 0.28. Okay, so they were still saying that p of x is equal to 0.12, and Lazari is saying 2.05, p of x is equal to 0.99. Okay, okay, fine. So just tell me what is the value of p of x. So approximately close to 2, right? P of x. Okay, so P of x, someone is saying 1.12. So again, we all are confused. Why you are giving me P of x is equal to like a 1.12? Because it's just a probability. So it should come in between 0 to 1 at any point of a time. So 0.88. So P of x is equal to 0.88 that I will be able to see. Okay. So fine, I'm taking a note of it. So probability P of x is equal to 0.88 that I will be able to see. Now, if I'll ask you, give me a value of this one based out of P of x. P of x is equal to 0.88. So your log is going to be, so can I say that this value is going to be a positive one? Yes. So this value is going to be a positive one any point of a time. So I'm just looking for two reasons. I'm not interested into your actual values, right? I'm just interested into your like a positive reason. That's it. That's the only thing which I'm expecting out of this one. Nothing else which I'm expecting out of this one. Okay. So the value that we have taken, so the x value that we have taken, for this x value, how many classes are possible? So can I say that it may belongs to a class number 1 and it may belongs to class number 0? Possible? Yes. Yeah. So here we have done some sort of experiments and we are able to get probability is equal to this one and log value is equal to positive. That is fine. We will do one more experiment over here. So value of x input will be same, but what I will do is I will try to keep value of m is equal to 21 and value of c is equal to -5. So let's suppose if I'm going to do a similar kind of experiment with value of m is equal to, so value of m is equal to 21 and value of c is equal to -5. Then give me an x is equal to same. So x is equal to 6.5 itself. So I'm not going to change the value of x for the same thing, right? Because I'm just testing it with the two different equation with two different lines. So I'm just trying to find out that which line is going to give a better accuracy or which line is going to create a better separations over there. So if these are the values, now what will be a p of x over here? So can I say p of x is going to be 1, right? So p of x is going to be 1 in this particular case. Yes. And yeah, so I can say that what will be 1 minus p of x is equal to 0. Okay. So p of x is equal to 1 and 1 minus p of x is equal to 0 in this particular place. This is what we are able to figure it out. Again, in this case, or if I'll try to find out this values, log values, so for sure it is going to give me a positive one, right? And p of x is equal to 1. So fine. Here we are able to observe one particular factor that yes, both of these things are going to do a separations in a better way. So although like I'm able to get a similar kind of a separation. So whether I'm using this value of m or c or this value of m or c, means whether I'm using this line or this line for this both input, it is going to give me a similar kind of a result. Can I say that? Similar kind of a result I'm able to get, right? Yeah. Some of you are saying, David is saying P of x is equal to 2.71. How it can be a 2.71? So P of x is a sigmoid function. Sigmoid function always gives you output in between 0 to 1. So practically that is not possible, 2.71. So I think there is some mistake you have made. Whatever value, even if you are going to give infinite values, it is going to give you a same result, like result between 0 to 1. So in both the cases, yes, I am able to get a similar kind of a values. So I can say that, okay, so both the algorithm is going to work fine. Now you can ask me one question over here, that when I can look into a data set. Now in this data set, you have said that, okay, so what we all are able to observe that y is equal to 1 for all the values lesser than 4 and y is equal to 0 for all the values lesser than 5, right? So here we have given two classes, our own classes, 1 and 0. This is our representation. So many of you will get confused that no, you said that it will be 1 and 0. Just try to understand one thing over here. It is not trying to learn your 1 and 0. It is trying to consider these things as a class. Let's suppose A and B class. One is equal to A and another one is equal to B. So it is just trying to understand that, okay, fine. So this belongs to what classes, not a number. So it is not associated with a number at any point of a time over here. It is just associated with the A and B classes that we have taken. And yes, our end goal or our end objective is to find out what? Just a probability. So yes, we are able to find out the probability. And again, in this case, I can say the probability is more robust and accurate. So if I'm talking about this particular probability, it's more accurate as compared to this particular probability. And even we have seen that with respect to this M and C values, we are getting some cost, right? We are getting some sort of a cost 0.33 or something. But with respect to this one, a cost is equal to 0. So now if I have to finalize a line, so can I say that I'm in a position to finalize this particular line as my final separator line? And based on that, so going forward, whatever input that I will be having, so I can try to do a calculation, a probability calculation for each and everything. So here someone is saying that why not use 0.5 values in a calculation anywhere? So see, the thing is, threshold is something that we can try to define by ourselves. So you are saying 0.5, but there is a possibility that I can try to keep a threshold is equal to 0.7. So whatever comes above 0.7, that will belongs to one classes. Whatever will come below 0.7, that will belongs to another classes. Threshold is something that we can try to manipulate. So again, just like a hyperparameter, we can try to do such kind of things. But yeah, so that is something that we are trying to learn over here. And finally, we are able to build a line which will behave like a separator, which will give me a probability. That was the whole idea, or that was the whole objective over here. Yes, so fine. Functionality wise, I'm not able to understand the difference of the logit and sigmoid. See, sigmoid always gives you a probability and logit always gives you a reason. That okay? So at the end of the day, both are doing the same task, right? So sigmoid is giving you the absolute probability so that you will be able to decide. And logit function, so log of p of x divided by 1 minus p of x, it is telling you that it belongs to one region or the another region. That's it. This is how you can try to distinguish between a logit function and a sigmoid function that we have. Okay, so now just try to understand that what will happen if I have a multiple variable or if I have a multiple features over here. So let's suppose if I have maybe x1, x2, x3, x4, x5. So in that case, how I will be able to calculate the probability? So in that particular cases, your probability is nothing but, or your p of x1, x2, x3 for everyone, or maybe I can write a capital X is nothing but 1 by 1 plus e to the power minus of, maybe I can say m1 x1, m2 x2, so on, plus c. So this is the instance where I'm talking about a multiple features x1, x2, x3, x4, x5. And if multiple features are given to me for a particular classes, so maybe this kind of a data set I'm talking about. So x1, x2, x3, x4, x5, and so on. And this is the y label which is given to me. So there are some values. Let's suppose I have, and class is equal to a. Again, some values, class is equal to maybe b. Some values a. Some values a. Some values b. So if this is the kind of a data set which is given to you, so in that case, this will become the equation. And with the help of this equation, so you are going to separate, or you are going to create, or you are going to find out the probability. So again, here we have to find out the multiple value of m and everything. So I think we all know how I will be able to find out the multiple value of m. So it's, this equation is approximately, so this equation is exact, I would say. So exactly similar to a multiple linear regression. So where we have a multiple values or multiple features, and for all of those features, so we are trying to find out what will be a correlation coefficient. Is error function and cost functions are the same thing? So yes, error function and cost function is the same thing. So you can try to distinguish between a loss function and a cost function. So cost function, just a name. So whenever we try to take all the instance or all the records or all the rows at a time, and based on that we are calculating a final error. So that is a place which is called as cost function. So cost function is nothing but when we are using a summation symbol. Loss, so error will become, or error will be equal to a loss. So when we are trying to calculate an error just based out of one single record. when we are trying to calculate a summation of all, in that case, that will become a cost function. So error will become a cost function. So that's the differences. Log of p of 1 minus x is not equal to mx plus c. That's why they give a value 2.05. The value of log of p of x is 0.88. Okay, yeah. So maybe they were giving a wrong result. So I don't know. So if the data set is non-linear, then we will use a logistic regression. Yes, you can use it, because here, so we are trying to create a separator. We are not trying to create a line which can fit over there, right? So even if I have a non-linear kind of a data set, I can try to take this one if there is a chance to draw a straight line. I'm just confused where we are using a logit function. So see, we are using actually a p of x. Logit function has been derived out of p of x itself. So logit function is not something different. So why we are using, or why we talked about a logit function? We talked about a logit function because if I'll ask you a question that, okay, can you please tell me that whether this is the line that you have drawn, now your data set belongs to this side of the line or this side of the line. Probability is something that I'm able to find out. Let's suppose I have given you an input data, and for that you are telling me probability is equal to 0.8, right? Probability is equal to 0.8. That's completely fine. Now probability is equal to 0.8 means maybe it's closer to class 1. Internally it's closer to class 1 and it's far away from class 2. So even in this way you can try to represent it, but logit function directly give you the prediction that, okay, fine, so in this region or this region, negative or positive region, so above or below the line, your data set has been represented. Always threshold value is 0.5. No, not always. SVM is similar to a logistic, but SVM uses a residual method to calculate the distance from the hyperplane. I'll be talking about it. So what is like how SVM and SVM SVR is different from your logistic function. So again, SVM XVR is kind of an extension of your logistic itself. So where we are trying to draw the hyperplane and we are trying to create a threshold, our own threshold. So I'll be talking about it. Can we solve a linear problem with the logistic? So linear in terms of what? So linear regression problem you're talking about, or classification problem? Now I understood the function of the logit. Thanks a lot. Okay, that's great. So yes, any other question that we have? So you can try to put up all those questions inside your chat box, and then I will be talking about evaluation matrices. So what and all evaluation matrices you are supposed to use for this one. So far, so forth, we were talking about what? So we were talking about just a derivation of the equation. So how logit or how logistic functions or logistic is different, and what logistic is trying to achieve over here. Can we fit a linear regression line in a classification problem? This is what we are trying to do, right? Please explain a cost function. See, just try to relate these things with the previous algorithm that we have studied. What is the cost function? And cost function is an entity which was helping you out to find out a difference between y and y hat. Simple. This is something called as cost function. Again, so it can be a MSC, it can be RMSC, it can be any other functions that I can use which will help me out to find out a difference in between expected y and the predicted y. Simple. Now here I have a expected y, right? So here I have a expected y, and apart from this, so I'm getting a predicted y. But if you will try to understand this one, so here you are trying to get a predicted y as what? A probability, p of x, and expected y again in 1 and 0, because internally it is going to consider each and everything as 1 and 0. So this is a cost function. So where, so let's suppose if I'm trying to talk about a binary class classification. So in case of a binary class classification, this is a cost function that you will be able to find out, which is nothing but a log loss function that we are trying to use. A logarithmic based cost function we are trying to use over here. We can't use just like a distance based calculation, because distance over here is not going to help you out in terms of calculating a error. So whatever will be a distance, so either of this side of line or that side of a line, it will not help you out in terms of calculating a final deviations from the actual classes basically. So here we are supposed to find out that interclass similarity, or we are supposed to find out that, okay, fine, so how close these two classes are or these two things are predicted one and the expected one, and that's the reason. So we are using log loss function in this particular place. How to set a threshold value. So we'll be talking about it. Why you're asking again and again same question when I've answered same question more than 10 times. The logistic regression has any assumption like a linear regression. So what assumptions in terms of what you are talking about? Okay. Now, so moving ahead, and before that, let me show you one particular slide over here. Yeah. So whatever we have discussed so far, so forth, again, in terms of our derivation, so each and everything is mentioned over there. So I was talking about this derivation, and I think this is the same derivation which we have already done, right? Everyone? Yes. So we all have done this kind of a derivation even in our previous classes, and that is the reason. So we have not discussed about this derivation in this class, because the way we are changing a weight over here is the same way that we have discussed in our previous classes. So this is the in the similar way. So we were trying to change a weights over there, right? And I think we all are aware about, like, this is the new, this is the old one, this is the eta, which is nothing but a learning rate. This is nothing but a derivative of a cost functions that we have used. And again over here, so we all are aware about the cost function. So what will be my cost function? So this is my cost function. This is a cost function that I have written. Yeah. So this is the cost function which I have written. So each and everything is mentioned over here in terms of a note, and for your future references. But again, nothing you have to remember. It's very, very easy. So even if you are trying to remember it, and you all will be able to make use of it. Yeah. Okay. Now moving ahead, and let's try to understand that how I will be able to find out the accuracy, because accuracy part is very, very important. And whatever we have discussed, right? So here in this slide, whatever we have discussed so far, so forth, you are not supposed to write even a single line of a code to perform these kind of things. You will just call a library, pass your data set, and your work will be done. Yes, some hyperparameter tuning, some grid search, you will have to do to find out the best possible parameter. But all of these things you are not supposed to do. These are just a theoretical aspect, and these things are useful to understand things in depth plus your interview. Because in an interview, so yes, you can expect some sort of questions from here directly. Generally, people will ask you, what is the cost function of a logistic regression, right? So what is the cost function for a binary class classification? What is the cost function for a multi-class classification? What do you understand by sigmoid functions? Why we are using a sigmoid function? Why not we are using some other functions, right? Apart from a sigmoid function, so why can't we use some other functions, right? Another like a probabilistic function. So these kind of interview questions which will be asked directly. Formula for a softmax. Okay, so how this softmax came in between, by the way? Okay, so someone has asked me just a formula for a softmax. I don't know whether some of you are aware about it or not. So formula for softmax is nothing but e to the power xi divided by e to the power summation of e to the power xi. So for example, if I have 1, 3, 8, and if I have to find out the softmax of 1, so it will be nothing but e to the power 1 divided by e to the power 1 plus e to the power 3 plus e to the power 8. This is something called as softmax. So maybe you are confused between softmax and sigmoid. So if you are talking about softmax, this is the formula and this is the calculation. Okay, so we use softmax in a multinomial. Okay, it should be a nomial, right? Softmax is for a multi-class probabilities. Yes, I have not talked about a multi-class, so just wait, right? So just wait for that one. I'm just talking about the binary class classification over here. So once I'll talk about a multi-class classification, then maybe you can talk about it. Okay, so now let's try to understand that what is the evaluation matrices I will be able to use in case of a classification problem. Again, this is a one-time job and very, very important. So when you will go for an interview, everyone is going to ask you that what kind of a matrices you have used to evaluate your entire model. So there are a multiple different kind of evaluation parameters and matrices I can try to use. For example, if I'll ask you a question, what is the evaluation matrices for a regression? So what you will say? What is the evaluation matrices for a regression problem that you have learned? So can I say R square and adjusted R square was a parameter, evaluation parameter, which I have used to find out the accuracy of a model. These are the parameters which I have used. I think we all are aware about it. If I'll ask you that what is the formula for R square? So 1 minus RSS divided by TSS, right? Residual summation of a square divided by total summation of a square. What is the formula for adjusted R square? So can I say that 1 minus R square into n minus 1 divided by n minus p minus 1? Yes? Yeah. So these are the things that you are supposed to remember for sure. That will be like a very, very important. So in the similar way, for a regression problem, we were trying to calculate an accuracy. We were trying to calculate the accuracy, can I say, based out of the distances and the expected distances? Yes. So based out of that, so we were trying to calculate the accuracy of the entire algorithm. Now here, in case of a classification problem, strategy will be different. And there is a different approach that we try to follow to find out accuracy of any algorithms, right? So what and all different kind of things which I have to know in case of a classification problem. Going forward, any kind of a classification problem, you can generalize it. So the very first one is a confusion matrices, right? Confusion matrices. Out of that, you will be able to find out accuracy. Now, the second evaluation parameter you should know is called as recall. The third evaluation parameter that you should know is called as precision. The fourth one that you should know is called as F1. The fifth one that you should know is called as specificity. The sixth one that you should know is called as area under the curve. The seventh one that you are supposed to know is called as RUC. So receiver operator characteristics. Receiver operator characteristic. So AUC, ROC. So these are the things that you are supposed to know in case of a classification. So the way you all have learned like R square, adjusted R square to evaluate your algorithm in the similar way. So these are the things which is very, very important when we are talking about a classification problem. And you should know, it should be on a fingertips, simple. So ROC is nothing but receiver operator characteristics. What is the meaning of this ROC? Why we are using ROC? So I think some of you have asked me a question that how this threshold is important. So by the time we will reach out to this AUC and ROC, I think you will be able to get your answer that what is a threshold and how we can try to change a threshold. Generally, people say that like a 0.5 should be an ideal threshold, but my answer will be no, that should not be an ideal threshold. We can try to change a threshold. My threshold can be 0.3, my threshold can be a 0.7. That depends, right? So based out of like a AUC, ROC, that's the reason. So I told you just wait. And by the time I'll reach out to this particular point, I think a concept will be clarified, right? So let's try to talk about these kind of things. So first of all, try to understand this particular part. What is a confusion matrices? A very first thing that which I have mentioned over there, which is required for any kind of a classification. So I think in your statistics class, we already talked about hypothesis testing, right? And confusion matrices. true positive, true negative, false positive, false negative. Yes. And I think we all have seen some of the examples as well, right? For each and everything. Okay. So fine. Here we are talking about, first of all, I'll be talking about two classes, and then I'll be talking about multiple classes, more than two classes. Let's suppose 3, 4, 5, or 10 classes we can try to discuss, because confusion matrix we can draw even for the multiple classes, not just for the binary classes. In general, it's a trend that we used to discuss just for the binary class classification, but confusion matrices can be drawn for any kind of any number of the classes that possible. So here, let's suppose if I have a class 0 and 1, right? So let's suppose if I have a class, I think we all are aware about confusion matrices, right? We all have discussed this confusion matrices in your statistics class. Okay. So let's suppose I have a class called as 0 class and 1 class, right? Okay, fine. So this is a actual value, or you can say this is my y. So y is equal to 1, y is equal to 0. Now y hat or prediction wise, let's suppose I'm receiving 1 and 0. So this is my y hat. So this one is representing on this side. This one is representing what? My prediction. And this one is representing what? This one is representing my actuals, right? Okay. So if my actual was 1 and if my prediction is 1, so can I say that I was expecting 1 and I'm able to get 1? So it will be nothing but a positive and truly positive. So I was expecting a positive result over here. Let's suppose 1 is representing a positive and 0 is representing what? A negative. I think we all talked about a hyperplane, a concept of hyperplane. So if greater than 0.5 positive, lesser than 0.5 negative. Agree everyone? So let's suppose 0 is representing a negative 1. Lesser than 0.5. So 0 is representing negative 1. This one is representing a positive 1. So this one is positive and this one is negative. It is trying to represent. So let's suppose I was expecting a 1 and I'm able to get 1. So can I say that I was expecting a positive and I have received a positive? Yes. Yeah. So can I say that it will be a truly positive? Means positive I was expecting and positive I'm able to get. Let's suppose I was expecting a negative result. Means I was expecting 0 class and I have received 1 class, right? So I was expecting actually a 0 classes, right? So because of my feature, I have given some input data, X data. I was expecting negative class or 0 class, right? And system has given me class 1. So can I say that it will be a positive prediction? Prediction wise, it is positive, right? But it is basically a false positive. Yes. So it is going to be false positive. So if I'm expecting 0 class and if I'm able to get what? So if I'm able to get a positive classes, means I was expecting 0, I got 1. So it's a false positive. Now here in this case, I was expecting positive, right? And I'm able to get negative. I was expecting positive basically, right? And I'm able to get negative. So can I say that falsely I'm able to get negative result? So whatever prediction, so here in this case, falsely I was able to get a positive result. So here I can try to say false negative in this particular case. Now here I was expecting negative, right? 0 class, and I'm able to get a 0 class. So can I say that it is basically a true negative? Yes. So I think we all are aware about this particular boxes: true positive, false negative, and true negative. I'm just trying to recall this entire things because some of us gets confused a lot. So when we try to create this particular box, so just you don't have to remember. So I don't remember this boxes: true positive, false negative, and true negative. So what I do is I simply do this kind of a thing. So I was expecting positive, I got positive. So true positive. I was expecting negative, I got I got a positive. So in that case, falsely positive, it is trying to give me. Then I was expecting a positive result, I got. So always you have to think in terms of a final prediction, a y hat. just remember the y hat part, right? Based on y hat part, this entire things is been calculated. So how this false positive name we are able to get? So can I say that we are focusing on what? So we are focusing on this prediction line or prediction part. That's the reason. So we have given falsely positive, right? So just try to keep these things in our mind. This is how I remember. I generally like remember this confusion matrices. So I'm expecting a negative. I got a positive, right? So whatever I have received, based on that, I can try to give a name, or I'll remember a name. So falsely positive result I'm able to get. Similarly, for false negative, I expecting positive, I got a negative result, right? So in that case, a false negative. So again, so this is just a way to remember or to memorize this kind of a things. So here, based out of this confusion matrices, I will be able to calculate a accuracy. As I have mentioned over here, that as I mentioned over there, so you can calculate the accuracy. So if I have to calculate the accuracy of, let's suppose I have built some of the classification model, right? So either it will give me 1 0 1 0 1 0 kind of a things. So I will be able to get y hat. At the same point of a time, I will be having y values, let's suppose, and then I'm trying to do a prediction, or I'm trying to find out the accuracy. So in which cases it is giving me as per the expected result. So can I say that in this case and in this case, it is giving me the expected result, means whatever I was expecting, I'm able to get the same thing. Yes. Yeah. So accuracy wise, if I have to talk about the accuracy, if someone will ask me that what is the accuracy of your model, what is the accuracy of your model? So what I will say is that true positive plus true negative divided by whole, all the data, right? So all the data means true positive. How many true positive we have? False positive plus false negative plus true negative. So this is going to give you an accuracy. So how many true positive we have? How many again? How many? I'm not talking about the value. I'm talking about the many. So how many of how many of classes were one? And yes, I was able to get one. How many of classes were actually expected as one? And I'm able to get zero, right? So based on that, I can calculate the accuracy. So again, this accuracy is coming out from where? From the accuracy matrix or this confusion matrices. There is different aspects of looking into the same thing. So you interchanged false negative, true negative place. False negative, true negative place. Have I interchanged? Is it? No, that is fine. So that is like a true negative, right? I was expecting negative, I'm getting a negative thing. So it will be a true negative. So it's correct actually. Yeah, it's correct. Okay, so accuracy is one of the criteria or one of the way by which I will be able to evaluate my entire system, or I will be able to evaluate my model. But accuracy is not the only way, because accuracy is not going to work, or you're not supposed to even believe on your accuracy all the time. So let's suppose if accuracy is coming as maybe 80% or 90%, so you are not supposed to believe on accuracy at all, right? There are some why we are not supposed to believe. So I'll give you one example over here. So let's suppose I have done an experiment. Positive represented by 1, negative represented by 0, again positive represented by 1, negative represented by 0. So let's suppose I have done maybe 100 experiment, right? I have done 100 experiment, and out of this 100 experiment, for maybe 20 experiments, right? So I was expecting 1. Yes, I was able to get 1. For maybe 40 experiment, I was expecting like a 0. I'm able to get 0. Let's suppose for a 20 experiment, I was expecting 0, but I have received 1. So which was the false positive? And for maybe less 30 experiment, right? So total is 100. So rest 30 experiments. So I was expecting what? So I was expecting maybe a 0. Sorry, I was expecting 1 and I'm able to get 0. That is completely fine. Now, if I'll ask you that what is the accuracy of this entire things? So can I say that accuracy of this entire things is nothing but 50%, right? Because summation of these things is going to give you a 50%, right? Okay. Now I'll try to change my statement over here. So maybe this is 10, right? So 20 plus 20, 40, and 30 is equal to 70 plus 10. So maybe I can try to keep this things as a 40. So this is now this will become 40. Yeah, this will become 40 over here. Now what will be the accuracy? 0.33, right? So 20 plus 10 is equal to 30 divided by 100 is equal to 0.3. So 0.3 is a kind of accuracy that you will be able to receive in this particular case. Now, why I'm saying that this accuracy is not a reliable term? The reason behind this one is in some of the cases, right? So in some of the cases, I can try to accommodate, right? Or I can try to accommodate, or maybe I can try to consider accuracy based on a more true positive that I'm able to get. So if you just observe in the previous example, so when I was trying to find out 0.5, my true positive was 20. Even this time, my true positive is 20, right? So in some of the cases, I'm just trying to focus on true positive. In both the cases, true positive is same. Yes. But can I say that accuracy has changed? My true positive has same, right? So let's suppose, so I'm just looking for maybe a total number of, I would say, the correct result it is able to give. So let's suppose there is a vaccinations, right? Which is a going one, ongoing things, which is I think every one of us are taking a vaccine nowadays, right? So here I'm just trying to look for all of those percentages. Maybe I'm going to calculate efficiency of vaccine based out of the kind of a true positive rate it is going to maintain, right? So that is the kind of accuracy matrices or accuracy evaluation criteria I'm trying to maintain. So, and based on that, so I'm trying to calculate the accuracy. So can I say that even if I'm going to keep my true positive rate is equal to same, but my accuracy is going to change if other factors are going to change, or especially my true negative is going to change. So in case of a classification problem, so accuracy is not always a reliable matrices that we are supposed to consider, because it depends upon my business use cases. So what kind of accuracy or what kind of evaluation or what kind of a final result which I'm expecting, and based on that final result, we are supposed to pick and choose our evaluation matrices or our evaluation criteria. So this is where another kind of accuracy matrices comes into a picture, or evaluation matrices comes into a picture, which is again derived from the confusion matrices. So the second one is called as a recall. In other words, this recall is called as sensitivity. Now, what is the meaning of recall? So if I have to write down these things as a formula, recall. So recall is nothing but your true positive divided by true positive plus false negative. So this is something called as a recall, right? So this is something called as recall. So what will be a recall in this case? Any idea? So recall is nothing but 20 divided by 20 plus 10, right? So 20 divided by, sorry, false negative, right? Okay, my bad. So 20 divided by basically 20 plus 30. So which is nothing but 20 by 50. So that is something called as a recall. So here recall is again another evaluation criteria. Now, what a recall suggests, or this is something called as sensitivity. So sensitivity of a particular model. So here in a denominator, you will be able to find out a true positive, right? And numerator, you will be able to find out true positive, and denominator, you will be able to find out true positive plus false negative. So this recall always tells you that how sensitive my model is in terms of giving a positive result, just a positive result, right? So how many positive results you will be able to predict correctly. This is something that it is going to tell you. So when government is trying to take a decision that, okay, whether I should release this vaccine for a public or not. So can I say that recall may be our best matrices as compared to accuracy matrices or no? In case of accuracy, so can I say accuracy was 0.3 with the same data set, right? But if I'll talk about a recall, so can I say that recall is equal to 0.4? So can I say that, okay, so if my vaccine is giving me a more positive result, right, and less negative result, so maybe in that case, I'm supposed to use a recall as a matrices to evaluate these things instead of using an accuracy matrices. So recalls always tells you how, so whatever positive result you are able to get, whatever positive result you are able to get, right? So how sensitive it is towards a positive result. Simple. This is the meaning of the recall you will be able to find out. Now, if the another matrix is precision. So what is the meaning of precision? Let's try to understand. So recall is one of the matrices, and precision. Now, what is the formula for a precision that you will be able to find out? So precision says that true positive divided by true positive plus false positive. This is something called as precision, right? So it always try to predict, or it would always try to measure again positive predictors, right? So true positive, it is trying to predict, right? So it is always trying to predict that whatever prediction it has done as a positive prediction, how many of this prediction was actually a positive prediction. So precision or recall always says that whatever prediction that I have done, right? So what is our sensitivity towards my actual prediction? So whereas precision always says that whatever positive prediction I have done, so how many of them are actually a positive prediction? That's the reason. So we have a false positive factor over here. So it always try to compare with the false positive and a true positive. Because if I'll try to if I'll ask you a question, that what is a total positive result you will be able to get, or what is the total positive result you are able to predict? A simple question. What is the total positive result you will be able to predict? So can I say that true positive plus false positive, both is having prediction is equal to what? Positive, right? But out of those positive prediction, how many of them are really positive? That is something precision is trying to tell you, right? That, okay, so you told me that, okay, fine, so your vaccine is good and it is giving you maybe accuracy is equal to 80%, but out of those 80%, how many of them are actually, or whether it's actually a 80% or not, or how? So you are saying that, okay, fine, so maybe out of 100, right? So it is going to cure maybe 80 people. This is something that you have claimed, right? That is the accuracy. But whether your precision is 80% or not, means whatever claim that you are trying to make is equal to your accuracy or not. So this is something called as a precision, right? So somewhere at some point of a time, so you can try to use maybe accuracy, you can try to use maybe precision, you can try to use recall, or in other words, it's called as sensitivity. Either of these three you can try to use, but there will be a problem again. So sometimes, so in some of the places, we try to take a trade-off between precision and a recall, and this is a problem you will be able to find out very frequently. And as I said, accuracy is not a correct criteria or correct matrices which you are supposed to use all the time. So when we will solve a multiple different problem, so I think we all are going to face this kind of a situation that somewhere we have to take accuracy, somewhere we have to take recall, somewhere we have to take a precision, and so many scenario based questions we are going to solve. So sometimes, so you will not be able to decide whether I should use a precision or whether I should use a recall. And in that situation, what we can try to do, so maybe we can try to take a trade-off in between, and we can try to use something called as F1 score. So F1 is nothing but it's just a mixture of, or it's just a trade-off in between precision and recall. So where you will try to keep a balance of actual positive result plus actual positive result out of the total positive result plus a sensitivity factor. So if you have to take care of both of these factors, so in that case, you can try to call precision 2 into precision into recall divided by precision plus recall. So F1 is nothing but a combination of a precision recall that you can try to use, and that we all are going to use it. But again, depends upon the different business situation that we are going to solve. So this is something called as F1 score. There is something called as a specificity. So specificity is nothing but true negative divided by true negative plus false positive. So it's always try to focus on the negative factor. So, but yeah, these are the things, or these are the like a criteria, or these are something that you are supposed to use to find out the accuracy of any kind of a classification problem, any classification that you are trying to solve. Now let's try to understand that what is the meaning of ROC and then AOC. These are the accuracy matrices, that is completely fine. But how ROC and AUC comes into a picture? Receiver operator characteristics and your area under the curve comes into a picture. So let's try to understand that part. If all of these accuracy gives a less accuracy, how to handle it? So in that case, you will have to start from the data part and the relation part and the equation part. So you'll have to probably change your data set, add more amount of data set. Maybe you have like a one class which is available in majority and other class which is available in minority. You will have to check that particular part as well, and many more things. So now let's try to understand ROC. So the full form of ROC is nothing but receiver operator CHRACTERISTIC. Receiver operator characteristic. Very important as far as your interview is concerned. So in many of the interviews, people are going to ask you a direct question plus scenario based question based out of this ROC as well as AUC, both for sure. So now let's try to understand what is the meaning of this ROC and what is the meaning of this AUC. So maybe it's 5:44. So we can, shall we take a break or shall we continue? Okay, most of you are saying break. So let's take a break for 10 minutes. So it's 5:44. So by 5:54, so we will resume, and we will try, because two things for today's class I have to explain you. One is a ROC and another one is a AUC. Both of this concept is very important for an interview. And then once we'll start like doing some practical operations, so we'll try to understand these things in a much better way. Yeah. So let's take a break, because that topic ROC AUC will take half an hour of time at minimum, half an hour to 45 minutes of time it is going to take. Yes, and many answers you will be able to find out, like a threshold answer and all those things. Will you also do practical today? No, practical won't be possible today. So practical, I think we can do it in next class. Because whatever we have established, whatever things we have practiced like theoretically, so we have to implement, we have to write a code for each and everything. Yeah. So fine, guys, take a break of 10 minutes. After a break, so I think we can resume and then we can start talking about these things. Yes. Hello, everyone. So I think we are back, right? Okay. So let's try to understand this ROC and AUC intuition, right? And this is, as I said, so this is very, very important. Again, not just for this algorithm. So again, going forward for all the algorithm that you are going to build. So this part is very, very important. And yes, in an interview, so this kind of a questions will be asked a lot. So here, the question is that what kind of a threshold we are supposed to select? As of now, we are saying that threshold should be equal to 0.5. Means if accuracy is coming lesser than 0.5, in that case, class 0. If accuracy is coming as more than 0.5, so in that case, uh, my classes will be equal to 1. In a binding class classification, let's suppose if I'm trying to consider. So I think we are all back, right? Yes, if I can get yes or no. Okay. Fine. So we are trying to understand that what kind of a threshold we are supposed to consider. So whether it's a 0.5 threshold, generally we try to say is a correct one, or maybe it's a incorrect one, or how we are trying to select. So 0.5 as a threshold. So it can be 0.3. So I can write an assumption that 0.3, so lesser than 0.3 is equal to 0 class, and greater than 0.3 is equal to class 1. So maybe I can write even in this way. Maybe I can write 0.7. So lesser than 0.7 will give me a class is equal to 0, and greater than 0.7 is going to give me class is equal to 1. So because at the end of the day, so what we are trying to calculate, a probability, right? Probability for each and every input that we are going to give. And just based out of threshold, we are trying to say class is equal to this or class is equal to that. And in an ideal situation, so we are trying to consider 0.5. Now, 0.5 is not an ideal situation, first of all. We are supposed to understand this particular part, right? Because it's just assumptions that we are trying to make. Again, assumptions based on the middle point we are trying to make over here based on the probability. So in this case, just to eliminate this kind of a confusion, or just to eliminate this kind of a doubt, ROC kind of a curve, receiver operator characteristics curve, comes into a picture, which will give you a very clear idea that, okay, so this is a threshold we are supposed to select for any kind of a equation or any kind of a model that we are going to build. Now, what this what is this ROC curve, or what is this uh, a thresholding point that we will be able to receive? So let's try to draw, or let's try to perform one very simple operations over here. So maybe I can try to build a confusion matrices, two confusion matrices over here. This is one. So maybe one as a positive, expected one, and 0 as a negative, expected one. And in on the prediction side, so maybe 1 as a positive class and 0 as a negative. And again, so we can try to draw a same confusion matrices. One as a positive and 0 as a negative. Again, 1 as a positive and 0 as a negative. This is for y hat and this is for y. Again, this is for y and this is for y hat. Now here, let's suppose if I'm going to consider 0.5 as a threshold, and over here, so 0.7 as a threshold to build this confusion matrices. Now I'm trying to do I'm going to do one kind of one simple experiment over here, right? So let's suppose this is my experiment table. This is my experiment table. So where for any input, X, I will be able to get Y, and I will be able to get Y hat, right? I will be able to get Y and Y hat. So for any input, 1, 2, 3, 4, 5, 6. So 6 experiment. Let's suppose I'm trying to perform. And here for all of this 6 experiments, so somewhere I'm expecting 1, somewhere I'm expecting 0, somewhere 1, again 1, 0, and 1. So this is the result which I'm expecting in actual, in terms of a data set. And maybe the predictions value which I have received, that will depends upon 0.5 probability, right? So here I can try to extend this particular table. And I can try to write 0.5 as a threshold, as a t value. And I can try to create another table where I can try to write threshold is equal to 0.7, right? Okay. Now, let's suppose for this input, this is the input which I'm going to give. So let me select some different color. Now, let's suppose for this particular experiment, I'm trying to receive actual probability is equal to 0.3. Again, actual probability is 0.4. 0. Let's suppose 6, 0.8, 0.1, and 0. Let's suppose 9. So this is the probability which I'm able to receive, right? Again, same kind of a probability I'm able to receive even over here. So 0.4, 0.6, 0.8, 0.1, 0.9. This probability value is going to be same. So let's suppose I'm using a same equation, right? But whenever I'm trying to calculate my y hat, so can I say that my y hat will be calculated based on the threshold? Yes or no? So can I say that whenever I'm trying to calculate a y hat, so it will be calculated just based out of my threshold, right? So whatever threshold that I'm going to consider, right? So based on that, I'm going to create my y hat. Okay. So no issue. So just y hat calculation based on 0.5. Let's suppose I'm going to write. So in this case, what I will do, so maybe I can try to select a different pen. So in this case, let's suppose for this threshold, so what is a y hat that I will be able to see? What is the y hat value? Threshold is equal to 0.5 and probability is equal to 0.3. So can I say that it will be 0, right? Okay, let me use a white pen itself. So can I say that this is going to be 0, right? Now for this one, this is going to be 0. This is going to be 1. This is going to be 1. This is going to be 0. This is going to be 1. Okay, fine. So based out of this 0.5 threshold, whatever outcome, whatever probability which I am able to receive from my equation, so this is my predicted y hat on 0.5. Now I can try to create maybe another extension over here, and I will try to calculate a y hat based on what? Based on 0.7. So what will be my y hat over here? So if my threshold is equal to 0.7, so can I say that it will be 0, it will be 0, it will be 0, it will be 1, it will be 0, and it will be 1. Agree everyone? Is it correct? Yes. So I think we all are able to understand the table, right? Now, if I'll ask you that are we getting a same accuracy in both the state when my threshold is 0.7 and when my threshold is 0.5? So are we getting a same accuracy in both the cases? No, right? So I think we are not getting a same accuracy in both the cases. Now, if I'll ask you a question that what is the accuracy we have over here and what is the accuracy we have over here? Yes, anyone? So 0.3 for 0.7 and 0.5 is the accuracy we are able to receive for this one, 0.5, right? So this is the accuracy that we all are able to receive. I think it's correct, right? I was expecting 1, I got 0. I was expecting 0, 0, 1, 1, 1, 1, 0, 0, 1, 1. No, I think accuracy will be more over here, right? So what will be the accuracy that I'm able to receive? So can I say that accuracy? Okay, just try to think in this way. So maybe I can try to delete this one, these numbers, right? Let's try to fill this two tables. So one for 0.5 and one for 0.7. Okay. So out of this 6 experiment, right? So how many of them are positive and we are able to get positive? So can I say that we had 1, 2, 3, right? 4 values as a positive, and out of these values, how many of them are giving me a true positive? So can I say that 3 data set is giving me a true positive result, right? Now, how many of these data set is giving me a false positive? So I was expecting negative, right? But I got positive. So how many of data set is giving me this kind of a things? So can I say that I was expecting negative and I got positive? I was expecting negative, I got positive. So none, right? So it's a 0 over here. Now, how many of this data set where we were expecting positive and we got negative? So I was expecting positive and I got negative with respect to a threshold. So can I say that for this data set, right? So for 1, how many data set we have? So where we were expecting negative and we got negative. So can I say it's a 2, right? So now if I'll ask you, calculate an accuracy. So what you will do? So 3 plus 2 divided by 3 plus 1 plus 2 plus 0, right? So what will be this number? So can I say that 83%? That's the reason I told you. So most of you are giving me 50%, which was not correct. So that's the reason. So we have done this calculation. So is this table fine with all of you? A table with 0.5% threshold? Yes. Okay. Now let's look into other side. Now let's try to see what is the accuracy I will be able to get. So we are trying to do a comparison of this one and this one. So this is a true Y and this is the Y that we are trying to do as a prediction. So here, how many Y we have as a positive and we have received as a positive? So can I say 2, right? So on this place and this place, so yes, we were having positive and we have received positive. Okay. Now for how many data set? So we had a negative and we have received as a positive. We had a negative and we have received as a positive. So can I say it's 0? For how many data set we had a positive and we have received negative? So we had a positive and we have received negative, right? So for this data set, we have a positive and we have received negative result over here. And for this data set, we have a positive and we have received a negative result. For rest of the data set, it's fine. So 2. Now, for how many data set we have a negative and we have received a negative? So can I say it's become 2? Now, what is the accuracy for this one? So 2 plus 2 divided by 2 plus 0 plus 2 plus 2. So basically 4 by 6. So can I say that 4 by 6 is nothing but approximately close to 0.67. This is the kind of a result I'm able to get. Now, what is a threshold I'm supposed to select? Whether it's a 0.5 threshold or whether it's a 0.7 threshold, because in 0.7 threshold, I'm getting 0.67 as an accuracy. And when I'm selecting 0.5 threshold, I'm getting 0.83 as an accuracy. So which one I'm supposed to select? Okay, most of you are saying 0.5 as a threshold I'm supposed to select. Just based out of the accuracy, you are trying to say this particular things, right? Which is completely incorrect. Let me tell you, it's completely incorrect. So you are just going after the accuracy. You are saying that, okay, fine. So 0.5 threshold is giving you 0.83% of accuracy. So I'll try to go ahead with that. It looks like, yes, we are supposed to go ahead with this one, but maybe this is not the case. right? And it's completely incorrect. So this is the reason, and this is a place where ROC comes into picture. So far, I have not discussed about ROC, right? That's the reason. So before that, I was talking about this two situation, just to like give you a clear idea. And I was expecting a similar kind of answer from your side. So this is not an answer. If you are saying that, no, I'll go ahead with 0.5 accuracy, I won't buy this particular argument. Then what we are supposed to do? Let's try to understand that, right? So answer is within this ROC curve. So we all will try to understand this particular things with the help of ROC curve. Now I'll try to plot this ROC curve over here, right? What happened to my pen? Yeah, so let's try to plot this ROC curve over here. And then okay, so then we can try to perform, or then we can try to find out, or we can try to do something over here. So in ROC curve, what happens is on your x-axis or on your horizontal line, we try to consider something called as false positive rate. And on this vertical curve, so we try to consider this as a TPR, true positive rate. So FPR and TPR, true positive rate. And ROC curve is nothing but it's a relationship between FPR and TPR, false positive rate and a true positive rate. And this ROC curve is going to give you a very clear understanding and an idea that which one you are supposed to select, which threshold you are supposed to select, whether it's a 0.5 as a threshold you are supposed to select, or whether you are supposed to select 0.7, 0.3, 0.4, or whatever it is. You can try to experiment with hundreds of a threshold, because in between 0 to 1, right, infinite number exists. So you can try to consider. So we'll try to compare these two, because as of now we can't plot this, otherwise we will end up like doing this calculation for infinite number of the instances. So here you are supposed to calculate a true positive rate and you are supposed to calculate a false positive rate. Now, how I will be able to calculate a true positive rate? Any idea? Anyone? How I will be able to calculate a true positive rate, TPR? Okay, so precision or recall, which one is a true positive rate? Yes, any idea? So which one is going to give you a true positive rate? Someone is saying precision, someone is saying again recall. So think about it. I think we have already discussed about this one. Recall we have already discussed, and precision we have already discussed, right? So which one is going to give you? Okay, someone is saying even a sensitivity. A TPR is nothing but so true positive divided by true positive plus false negative. So true positive divided by true positive plus false negative, whether it's a precision or whether it's a recall. Okay, so it's a recall, right? Okay, so fine, we can try to calculate this true positive rate, right? Or a TPR for our entire equation or whatever like we have. So what is true positive rate that we have? Can anyone calculate true positive rate? I think we already know the formula of this recall or sensitivity, right? So anyone who can tell me what is a TPR for 0.5 and what is a TPR for 0.7? No, I'm talking about 0.5. So what is a true positive rate for 0.5 and what is a true positive rate for this one, for your 0.7? Okay, so let's do a calculation. Let's do a math. Yeah. Okay. So TPR is nothing but, so how I will be able to calculate a TPR? So TPR is nothing but, so true positive. So what is my true positive? True positive is equal to 3 for 0.5, right? So let's, where is my pen and pointer? Okay. So TPR, we can try to calculate over here. Now TPR is nothing but, so true positive. So I think true positive is equal to 3 in this case, right? So 3 divided by what I can do. So I can try to do true positive plus false negative. Which one is my false negative? Yes. So falsely negative. So can I say 1? So 1. So 3 by 4. So what is a 3 by 4? 0.75, I believe, right? Okay, fine. 0.75. Now, false positive rate. What is the meaning of this false positive rate? Yes, any idea? So what is this, like a false positive rate? So false positive rate is nothing but 1 minus, I would say, a specificity. Or I can say false positive is nothing but false positive rate is nothing but 1 minus a specificity, or a true negative rate, or I can say 1 minus FP divided by 2 negative plus false positive. Yes, everyone? So 1 minus 2 negative divided by, so 1 minus false positive divided by 2 negative plus false positive. So what will be a value of this one, FPR, for just 0.5 threshold? So this is something called as specificity. This one, this part is called as specificity, or in other word, it's called as true negative rate. Yeah. So 1 minus, how many false positive we do have? So false positive, someone is saying 1, 2, someone is saying 0. Okay, so I think you should look into, you are really confused with respect to a confusion matrices, I believe. False positive is this one, right? So false positive is 0 in my case. Okay, so false positive is 0 in my case. So FPR for this one is going to be 0. Sorry, FPR is going to be 1, FP is equal to 0. Okay. Now, same thing we are supposed to calculate for 0.7 threshold. So TPR. What is TPR, by the way? So can I say TPR is nothing but 2 by 2 plus 2? Yes. So it is going to be 0.5. And what is my FPR? So my FPR is going to be 1 in that particular case. Okay, that's great. So TPR and FPR, we all are able to find out. So in this case, so TPR is 0.75 and false positive rate is equal to 1. So TPR, let's suppose this is ranging in between 0 to 1, right? This is ranging in between 0 to 1. This is ranging in between 0 to 1. Now, so if I have to plot this particular point, so false positive rate, let's suppose 1 somewhere over here, and true positive rate 0.75, so maybe somewhere over here. So I will be able to get a point in this particular place. I will be able to see this particular point. Now TPR, so true positive rate in this case, right? So true positive rate is equal to 0.5 and false positive rate is equals to this one. So somewhere over here, I will be able to get this particular point. Agree, everyone? Yes? Specificity formula is wrong. Yeah, you can check that up. So even sometimes I get confused between these many formulas, right? Specificity is nothing but a true negative divided by true negative plus a false positive. So that is the formula. So what I have written, by the way, okay, sorry. So specificity is nothing but like a true negative. Sorry, my bad. True negative divided by true negative plus a false positive. Okay, just let's try to do a calculation, guys, quickly. So what will be a FPR in this case? Yeah. So FPR is 0 in both the case. Okay, fine. So FPR is 0 in both the case. Let's suppose. Fine. FPR is 0 in both the cases. Okay. So in that case, if FPR is equal to 0, right? So if I have to plot a point, so maybe true positive rate is equal to, I can try to plot 0.75 and 0.50 over here. 0.50 in this particular place. So this is the red dot, which is representing. So this red dot is trying to represent what? For a 0.5 threshold. And this dot is representing itself for what? So for basically 0.7 threshold. Now here, in between these 2 points, which one you are going to select in ideal situation? So if true positive rate, so in one cases, our true positive rate is high. In another cases, our true positive rate is low. And if I'm talking about a false positive rate, right? So false positive rate is equal to 0 in both the cases. So false positive rate is 0 in both the cases. So which one we are supposed to select? So can I say that can we 0.75 should be higher than 0.5? No, when we are talking about a true positive rate, so let's suppose if I'm trying to build a use cases, so where I'm expecting more positive values as compared to a negative values, right? So I'm going to accept a model where, so I have a criteria, so where I'm accepting a model, so which is going to give me a more positive values as compared to the negative values. So in that case, can I say 0.5 threshold is going to give me a more positive values as compared to the negative values? Agree? Yes. So if I'm trying to like build a use case, let's suppose I'm talking about the healthcare. I'm going to release some of the medicines, right? So when I'm trying to do a trial of the medicine, so at that point of a time, right? So at that point of a time, what is a threshold I'm supposed to select? Is it a 0.5 or is it a 0.7 as a threshold I'm supposed to select? So some of you are saying 0.5, 0.5 as a threshold because you will be able to get a more positive rate. Yes. So 0.5 is a higher one, which is giving you like a higher one in this case. So yes, that is a general assumptions that you are going to select 0.5 in case of a or more true positive rate. For sure, you will be looking for in case of a healthcare use cases. So is it true? Is it really true? You are supposed to select 0.5 in healthcare? Because my opinion is just a reverse of this. So I'm going to tell you that we are supposed to select 0.7. So we are not supposed to select 0.5. See, you are getting more positive result, right? In case of 0.5. And in case of 0.7, if you are going to keep as a threshold, you are getting more negative result. So can I say that in case of a medical trial, I will be looking into a more false positive rate and I have to improvise, I have to work on more false positive rate. So let's suppose there is a medicine I have given to 100 people, right? So maybe on an average, it is going to cure 70 people. That is completely fine. But what about these 30 people, maybe, if it is not able to cure? So can I say that I will be looking for an improvement into that negative side? So in that case, I'm supposed to select which one? I'm supposed to select threshold is equal to 0.7. A high threshold I'm supposed to select for getting a positive classes, so that I will be able to build a better medicine. I will be able to test a medicine in a better way. If I'm talking about a medical use cases, yes. Yeah. Now, second use case, let's suppose I'm going to consider. Government is trying to launch one policy, right? So recently, government has launched so many policies, Jan Dhan Yojana, or maybe like for a farmer. So they have launched many different kind of agricultural policy, or maybe kind of insurance policies government has launched. Now, in that case, which one is a threshold I'm supposed to select? 0.5 or 0.7? So can I say in that case, I'm supposed to select 0.5, right? So I'm supposed to utilize this model, right, to majority of the people. And again, there is no harm in that one, right? There is no constraint which will come in between. So in that case, I'm supposed to select 0.5, so that many people will be able to get a benefit of it, even if we have more false positive, right? Even if we have more false positive, but still we are supposed to select that one which is giving me, or even like which is giving me a true positive rate. So this is something called as like a ROC AUC curve, and it's always a contextual thing. So whenever we talk about a ROC and AUC curve, it's always a contextual thing, and whenever we talk about a threshold, it's again a contextual thing. It depends upon which kind of a use cases, or which kind of a model, or for what purposes we are going to build a model for what businesses, and based on that we always try to select the cases, or we always try to select whether like this is the threshold or that is the threshold. So let me try to talk about ROC AUC curve in a very generic way, and I think this will clarify uh, many more things at any point of a time. So let's suppose there is a model I have built, right? There is a model I have built, and I'm trying to test my model for a different thresholds, right? So let's suppose this is representing a true positive rate, and this is representing basically a false positive rate. Now for this true positive rate and false positive rate, right? Let's suppose we have so many points. We have TPR is equal to this one. We have TPR is equal to this one. We have TPR is equal to TPR versus like FPR is equal to this one. We have this one. We have this one. We have this one somewhere, and we have this one, right? Okay, so let's try to connect all the dots over here. Okay, now, so this is all this dot is trying to represent FPR versus TPR, a false positive rate versus true positive rate, right? Now, can I say, so, and all these things is representing a different threshold. So let's suppose this is representing 0.32 threshold. This is representing maybe 0.5 threshold. This is representing maybe 0.3 threshold. This is representing maybe 0.7 threshold. This is representing maybe 0.6 threshold. This is representing 0.8 threshold. This is representing 0.9 threshold, right? Now, out of this many threshold, last time we have tested for 2 threshold. That's the reason. So we were not able to draw this many like dots or this many points. Let's suppose this time I have drawn these things, and this is the graph which I'm able to get a true positive rate versus false positive rate. Now, which one is a threshold I'm supposed to select, right, for a government scheme? My question is very clear. Again, a contextual one, that which one is the threshold I'm supposed to select for a government scheme. So someone is saying 0.9, someone is saying 0.62. So you will end up taking, I think, all the numbers, right? I think I have already given you the threshold points. So what, which point? So what is the threshold which I'm getting or which I'm trying to receive? So for government scheme, so what will be a threshold I'm supposed to select? 0.2, 0.2, 0.8. Okay. So can I say that for a government scheme, so I will be looking for, right, more TPR, true positive, right? So TPR should be high and APR should be low as possible, and or maybe a balanced one. I will be looking for a place where false positive will be less and true positive will be high. Agree everyone? Yes. Yes. So what is the point which is representing, what is the threshold point which is representing a high TPR and low FPR? So can I say that this is a point? Where is my pen? Yeah. So can I say that this is a point which is representing a high true positive and a lowest false positive, or high TPR and a low, and if I'll talk about this point, right? So again, TPR is low, although APR is low, but also TPR is low. So I'm not supposed to select this one. I'm supposed to select something where TPR is high. I can select even this point. There is no issue with that, right? But again, FPR will increase over here. So for a government scheme, I'm looking for a high true positive and a low false positive over here. So this is the only ideal point which I will be able to see. So where I have a high TPR and a low FPR. So can I say that? Are you able to understand this particular point? Yes. So we are looking for a high true, like a positive result as compared to a low FPR. So what will be my threshold? My threshold is equal to 0.3. This is the threshold I'm supposed to select. So whenever you are building a model, you are not going to test it. So by default, model will take threshold is equal to 0.5. But whenever you are building a model, you are supposed to build a model with a different threshold. So whatever y hat that you are trying to generate, so you are supposed to generate with respect to a multiple different threshold. And then based out of that, you are supposed to draw this ROC curve, right? TPR versus FPR. Just y and y hat, if we are able to get it. So I think I will be able to get a confusion matrices. Then I will be able to calculate TPR and FPR, right? And then I have to look into a business use cases. So whether business is looking for a high positive or a low, like a positive. And based on that, so we can try to test, or we can try to finalize a thresholding value. So this is a method to threshold, to finalize a threshold value. So ROC is nothing but at any point of a time, receiver operating characteristic curve is going to tell you that what is a threshold you are supposed to select, or you are supposed to pick and choose to build a particular model. Is it making sense to everyone? Are you able to understand what is uses of like ROC? Now I'll give you another situation. Same graph, situation is different. Business case is different. Let's suppose I'm talking about court, right? So courtroom. So basically, like, court will try to decide so who will be guilty and who will be innocent, right? So in that case, what is the threshold? Let's suppose this is the model which I have built, and this is the TPR versus FPR. Now in that case, what is things I'm expecting? Yes. So if I'm talking about a court, right? So in that case, what I'm expecting? So can I say that I'm expecting the lowest level of false positive? If person is not guilty, if person is innocent, right? So you are supposed to release them. Even if person is not innocent, but if you're not able to prove, but still, so our like a court says that, our like a law or IPC says that maybe you can release hundreds of criminals, but at the same point of a time, you are not supposed to punish one single innocent person, right? So can I say that I will be expecting a lowest level of FPR? Yes, the lowest level of FPR, and at that point of a time, maybe highest level of true positive rate. So in that case, can I say like a 0.6 will be my ideal number? Agree? Everyone? Yes? Okay. Let's talk about healthcare cases. Medical trial, right? Or maybe some like a vaccine trial, if I'm talking about. So in that case, what would be the ideal situation? So what is the threshold I'm supposed to select? So what is the threshold I'm supposed to, so whether I should go ahead with the more FPR or more TPR or balanced one, what will be the situation? So can I say that lowest TPR and FPR. So can I say that? Okay, so lowest FPR, false positive. And can I say I will be expecting maybe a highest TPR, true positive? So as less as possible FPR, and maybe I will be expecting a very high true positive rate. But at the same point of a time, I will not be able to neglect a situation where my medicine is going to give me a false result or false positive, right? So can I say that again in that case 0.6 can be my possible like a number, or maybe 0.7. So 0.6 will be an ideal one where, because my false positive is 0 over there in 0.7. So we have some false positive which we are not supposed to accept. Yes. So in medical use cases, can I say that FPR must be minimum and TPR? So generally TPR should have a neutral one, right? In that case. So what is the things which I can select? So maybe I can go ahead with 0.6, 0.8, 0.9, right? We are not supposed to get any kind of a false result over there. But in this case, so maybe we can go ahead with 0.9, 0.8 or 0.6. So this is how we are supposed to select a threshold. So I think we all are able to get an answer, right? And it is a contextual one. There is no straightforward result or there is no straightforward answer. So whenever you are trying to answer something, so based on, so where you are expecting more true positive and where you are expecting a less false positive or high false positive, based on these cases, you are supposed to select a threshold, and that criteria you will be able to get out of the ROC curve. So this is something called as ROC curve, receiver operator characteristic curve. Yes, so ROC is actually based out of the situation. Now let's talk about AUC, area under the curve, right? So let's suppose I have built a multiple models. So in our cases, you must be able to see that we have taken a multiple value of M and C. Agree, everyone? So here M is equal to 5, to M is equal to 21 minus 5, M is equal to 0.3, 0.1. So can I say that we have taken a multiple value of M and C? Yes. So if I'm taking a different value of M and C, can I say that I will end up building a multiple models? Agree, everyone? So if I'm taking a multiple different value of M and C, so I will end up building a different models. This is what it means, right? All the time. So multiple model I will be able to build at any point of a time. Fine. Now for every model, can I say that I will be able to draw ROC curve? For every model, I will be able to draw the ROC curve for a different threshold. So one model, different threshold, right? Then we can try to finalize a threshold. Then another model, again different threshold. So three model, so three value of M and C, three distinct value of M and C if we have taken, I will end up building three models, three different models in this particular case based on our situation, right? And for every model, each and every model, so I can try to do the same thing. 0.9, 0.8, 0.6, 0.7, 0.3, 0.5 is a threshold, just to decide that, okay, fine, so what will be my threshold? But let's suppose, right? So let's suppose I have decided that for one model, 0.3 is a threshold, for another model, 0.5 is a threshold, for another model, 0.7 is a threshold. So different threshold I have decided, right? But at the end of the day, out of this three model, right? So let's suppose all of this three model is giving me approximately similar kind of accuracy, or maybe I'm confused that which model I'm supposed to finalize. Because if you will see a model number one with M and C value, I think 5 and 2, and a second number model 21 and -5, both of them were giving me approximately same result, 100% accuracy, right? And the last one, so where I have taken maybe 0.02 or something, so we were having a different we were having some sort of a loss over there. So if out of a multiple model, if I have to select one model, right? So ROC curve, I will try to build for all of these three models. So let me do that. And then maybe I can try to explain you what is AUC. So let's suppose I'm going to consider again model number 2. And this is the ROC curve we are able to get, this blue one, right? So white one, this white one for model number 1, this blue one for model number 2, and then I'm going to draw maybe next one, right? So this is my model number 3. So my red one is model number 3, my white one is a model number 1, and my blue one is a model number 2. Now out of this 3 model, I'm just confused that which model I'm supposed to finalize, right? So this is where area under the curve AUC comes into a picture. So whatever ROC, so this is a ROC, this is a ROC for one model, this is again ROC curve for one model, this is ROC curve for one model. Now which model is covering most of the area? So this model is covering this much of area, right? This white model is covering this much of area, and this blue model is covering this much of area. So which model is covering most of the area? So can I say that model number 2, a blue one, is covering most of the area? So in that case, which one I'm supposed to finalize? Model number 2. So the uses and significance of area under the curve is nothing but to pick and choose a model. Let's suppose same problem I'm trying to solve by using a different algorithm. One algorithm is logistic regression, another algorithm is decision tree, another algorithm is XGBoost, right? So 3 algorithm I have used, or even by using a single algorithm. So I have used maybe a different model, because I will change a value of M and C and I will end up getting a different model. Straightforward, I will end up getting a different model, right? So for every model, I will try to draw ROC first of all. So once I will be able to draw like a receiver operator characteristic curve, right? Then I will try to check which one is trying to cover most of the area. That area is called as area under the curve for an individual model. And AUC is going to tell me that, okay, so final model wise, which model I'm supposed to select out of the multiple models that we have built, because inside the industry, we always build a multiple model for a same use case, for the same data set, for the same feature and a same label. We try to build a multiple model so that we can try to understand and we can try to check that which one is trying to learn my relations which is available inside a data set into a better way. But how to do a selection out of this multiple models, 5 model, 10 model, 20 model that we have built based out of your AUC. So this is the uses of AUC. Hope you are able to understand the meaning of AUC and what is the uses of ROC. Yes. So ROC is being used to set a threshold, to identify that, okay, fine, so what will be my ideal threshold? And that is a contextual thing. It depends upon the business. So unless and until you are not having idea about the business, or unless and until person is not giving you this business situation, you are not supposed to give an answer. You should not say that, no, this will be the like a threshold for me, just based out of the ROC curve. You should ask a person immediately. And person will be able to understand that, okay, fine, so this person is aware about ROC in a true manner. Yes. And then if I'm talking about the AUC, so AUC is simply out of the multiple model, if I have to select one single model, so area under the curve is something which is going to come in between. So hope this complete idea is clear. So ROC is to set the threshold, AUC is to select a model. Yes, that's correct. And AUC is nothing but it's coming out of the ROC, because the curve that you're trying to build. So just the area we are going to consider under AUC, right? But AUC curve is been built out of what? Can I say out of ROC? Yes. So always remember that. Don't get confused that, okay, fine. So how I will draw the ROC curve? No, AUC curve. We are not drawing AUC curve. We are drawing actually ROC curve, right? And inside that curve, so whatever area that we are going to get, that we are calling as a AUC. Simple. Yes. So why AUC always like AUC is not clear? Why high AUC? Why not low AUC? Okay, let's try to understand in this way. So let's suppose I'm talking about this blue one, right? Or maybe I can draw a different graph over here. Again, see, I'm just talking about this entire things in a very first class because we will end up using these things again and again and again, many times, right? So if you are clear or if you are able to understand even a 50-20% from a beginning, so by the time we will cover 10 plus algorithm just in classification, you will be just pro in each and everything, right? That is the reason. So I'm talking about these things in a very beginning. Simple, because this will be a repetitive things, and again I'll keep on talking about AUC, ROC, precision, recall, sensitivity, right? True positive rate, false positive rate, each and everything. So that's the reason. So yes, those who are able to understand it completely, it's fine. Those who are not able to understand, it's also fine. Even if you are able to understand 10% of it, because yeah, these things are like a little bit confusing things for sure, and you have to like sit peacefully and think about it. Again. So let's suppose this is my ROC curve. This is one of my ROC curve that I have. And this is my second ROC curve that I have. Let's suppose over here we have a TPR and over here we have FPR. So true positive rate and a false positive rate we have in between. Can I say that, okay, let's suppose this is model number 1 and this is model number 2. Can I say that model number 1 is trying to acquire more area, right, as compared to model number 2? Again, it's a comparative study, right? So model number 1 is trying to acquire a more area as compared to model number 1. Now, what is the meaning of it? So can I say that every point of this particular curve is nothing but it's a point, or it's basically representing a relationship between a true positive rate and a false positive rate, right? Every point on this particular curve, whether it's a M1 curve or whether it's a M2 curve, so it is trying to represent what? It is trying to represent true positive or false positive rate versus true positive rate is trying to represent, right? Means how accurately it is going to give me a prediction. This is what it is trying to represent, right? Okay. So here we are saying that if I have two model number 1 and model number 2, I would prefer to use model number 1 instead of using a model number 2. There is a certain reason behind it. So I'll prefer to use a model number 1 as compared to model number 2. Why? What is the reason? So can I say that for every same threshold, let's suppose, or whatever like a threshold that we are trying to take over here, for every threshold value, let's suppose this threshold value is like a same, and I have just like tested it for a same kind of a threshold, right? It is trying to give me a low FPR. If this is the above curve, it is giving me a low FPR somewhere and more true positive. So this model will be much more stable as compared to the inner model, right? So it is able to maintain its true positive rate, or as your model will progress or as your threshold is changing, right, it is able to maintain it at any point of a time, a relationship between a true positive and a false positive. And because of that, right, so the model number 1 is getting or giving you a more area, and that is one of the reasons. So whenever we look for the model, we always look for the stability, and this is the kind of a stability which will be defined by your AUC. That is the reason. So we always say that whichever ROC is giving me a more area under the curve, so I'm supposed to select that particular model. So that is my answer. How area under the curve is calculated? So it's again very simple. So if I have to calculate the area under the curve, so this is like a 1 by 1. So can I say that this is 1 cross 1, right? So true positive rate will be in between 0 to 1 and false positive rate will be in between 0 to 1. So can I say that we have a unit square over here? So 0 to 1, 0 to 1. And if I'm aware about the coordinates, so I will be able to calculate all the points inside this one or all the areas inside this one. Yes. So based on that, selection of model will vary based on the use cases. Yes, that's true. But again, so this is AUC is going to tell you very clearly that this is something that you have to understand. Confusing TPR and FPR. No, that is not confusing at all. So I think you should go ahead with these things once or twice. You will be able to understand. And like I said, so it's kind of a repetitive things. We are going to repeat it again and again and again, so many times. almost more than 10 times we are going to repeat our same things. So that is the reason. So once I have discussed these things in your very first class, going forward, you will do. You will be able to revise it again and again, and for sure you will be able to recall each and everything. Okay, so fine, guys. This is it from my side. So hope you have enjoyed this class. Hope you are able to understand this each and every concept. This each and every concept is just a base concept. I think we all are supposed to aware about it. Yes, recall. Yeah, and even if you are able to understand like a 10%, 20%, it's completely fine, as I have mentioned. So it's going to be a repetitive one. Yeah, so please try to revise it. This is my humble request. If possible, try to discuss the earlier completed assigned tasks by you in the classes. Submission. Yeah, I'm planning for that. So for sure, Kushal, I'll try to discuss all of those tasks, 5 to 6 tasks back to back. So maybe I'll just dedicate one of the classes to discuss a task which I have assigned, and again from your side. I think we need to interpret these matrices with the use cases. Exactly. Yeah. So have a great day, son. Thank you so much. Maybe explain TPR why the lower value are placed higher on a chart. No, true positive rate was low, and uh, yeah. So I think okay, lower value is placed. Which one you're talking about? I think you're talking about this part, Anuj. Yes. So see, here is 0.7 is not a TPR. Your TPR is what? For 0.7, what is the TPR that we have received? 0.67. This is the TPR. I think you are able to see my cursor, right? And for 0.5, so 0.7 is basically a threshold I have given to you over here. Just try to observe, right? So 0.7 was actually a threshold. 0.7 was actually a threshold over here. It's clearly visible. So this 0.7 is representing this particular threshold. Its TPR is 0.67. So this TPR is basically 0.67, and this point is representing TPR is equal to 5. What? 0.75. So TPR is high for 0.5 threshold and TPR is low for 0.7 threshold. Hope this is clear. Yeah. Thank you for explaining the concept. Actually, it was too much to take for today. I would like to revise all the things on that. Yeah. See, this is important. And again, so this is a kind of a stuff that we have discussed, which we can utilize it again and again. I'll recommend you to revise it once again. I'm a new joinee. I would like to know where I can get the Jupyter lecture notebook in my dashboard, which you have shown in between the session. Okay, so whatever I have discussed in between the session. So if you're going ahead with the live class recording, you will be able to find out live class material link, I believe. Click over there. All the materials are available. Right, guys? Everyone? Yeah. So yes, it is available over there. And if you're going ahead with the previous class recording, Linto, I believe. Linto, right? Yeah. So if you're going ahead with the previous class recording, so in that case, it's available in the respective session. There is a folder called as resource folder. Also, with the business team, we need to ask many questions mainly to get the clarity of the problem. Yeah, that's correct. Can you please upload the scratchbook too? Okay, let me check whether I can download it or not. I think I can download it, right? Tablet from background table. Okay, export image, PNG, and logistic regression. Okay, so this one will be available in SVG format, I believe, and you all can expand it and you, oh yeah, so this is available. So maybe you will have to zoom in and you all can see. SVG format is not that clear when I'm trying to zoom in. Let me import this entire thing in some other format. Port and PNG format. linear regression PNG. So is there any other way by which we can try to get? I can upload this one, but I believe this one is not that. Okay, maybe will take some time. Okay, export into high quality option. So where is that option? Accessibility checker. Okay, maybe I can do Control P. Export and okay, high quality image. Last time I have done that, right? SVG. Okay, last time maybe by mistake I have opted for, sorry, Logistic. VG. So, okay, maybe H. It is not able to open up. With Chrome, Microsoft Edge. Yeah, now it's fine. So I believe you all will be able to expand it and then you can check. So fine guys, I'll just like upload this one inside your dashboard, right? This notes inside your dashboard so that you can try to go through it whenever you want, right? So yeah, this will be available. Yeah, one of the very first class you have used Miro. Yes, I was using Miro and I was like get used to it. And then in a later stage, so I have started using something else. So I just left that one. Please give a notebook also. Yeah, that will also be uploaded. Don't worry. Yes, so I have shown you one logistic regression notebook. So even that will be available. What app you use to open? Anyone. I think you can use any browser that will work fine for you. Yes, I believe. Okay. So fine, guys. With that, thank you so much. Just a revision is required. Whatever we have discussed, each and every piece of things we are going to utilize in our next classes, right? So come to our next classes without any kind of a confusion. I think you already have a challenge for next 2 weeks. I have already given to you. So please try to like do that. Apart from this, those who are facing an issue with a deployment, right? So those who have already dropped me a mail, I think we all know where you have to drop a mail. So I have just redirected all of you to Vikas, so who was available in today's class, and he will help you out with all of your issues, whatever you are facing with respect to a deployment. Right? Those who have not dropped a mail, those who have not tried this deployment part, you can drop us a mail again. I'll redirect you to Vikas and he will arrange a call, right? I got a reply 8 p.m. He has arranged. Yes. Yeah. So he will try to arrange this discussion for you. He will look into your system. He will try to resolve your issues, right? So simple. I got redirected to Sivan. Please connect me with Vikas. So even Sivan will do it, or maybe I'll just ask Sivan to redirect you to Vikas, because whenever I receive a mail, right? So I just react like your query based on your different like requirements. So if your requirement is different, then for sure it will go to a different person from our team. Simple. Yeah. Okay, so with that, thank you so much, guys. Hope you have enjoyed this class. Thank you so much, Nilesh. So hope you have enjoyed this lecture, right? And you will be able to remember each and everything that we have discussed in today's class. I'm just expecting this. Simple, exhausting session. Yeah, I know, even for me. So okay, with that, thank you so much. Thanks, ACJ, PJ. Yeah, thank you so much. Thanks everyone for Teachers Day. So thanks.